Now recording. Welcome everybody. Tonight is the 20th of July in Dallas, or the 21st and Wednesday in parts earlier in the time zone map than Dallas. I'd like to welcome everybody to Dallas Personal Robotics Group Robot Builders Night Virtual, and we'll just do the usual and go around the table and talk about projects we've been working on, questions we may have, or whatever other specs are fancy. My name is Carl Ott, current president, and I will ask later on, so keep your thoughts in mind, that we do have certain outdoor contests coming up pretty soon in 14th of August, I think it is. And we have, it's 21st? 21st of August, right, 21st of August, because the 14th of August, I'm in a wedding somewhere. So 20th of August, whatever that is, the third week, we have a contest, and somehow we need to tally of who's going to be doing it from Dallas and regions outside of Dallas. So at some point, let's have that chat. But before we go there, why don't we just start off, and Pat, if you could lead us into discussion, take it away.
Okay. Last time, a couple of weeks ago, I had discussed the new robot, the mobile platform I had, the four-wheel drive. I've been getting it going since then. I've gotten it rolling, working on the remote, powered everything up by battery, so that seems to be working good. I've been testing my MQTT background, essentially data server, to transfer everything between my programs. So I've got different Python programs that are launched from a bash script. And that basically allows me to utilize the full processor, not just on one core if I launch everything in a threading process. So that's been good to level the performance across all the cores on the Pi. Having a bit of mixed luck with the latency and transmission from MQTT. It's I'm trying to get it sent out every 50 milliseconds. And I'm getting usually around 50, 52, 49, 48. And occasionally I will get it like 62. So far, I've created in my programs, if I don't receive data after 100 milliseconds, stop whatever process it's running. So if I lose connection to the main program, the arbitrator, the wheels will shut down. So there's no more motion or thing. So that's been working pretty good. I'm in the process today. I've been working on, I don't know if you guys can see this. I've got a little ultrasonic array assembly to go on the front of the robot. And it's got a little nano on the top. Basically, I'm going to be blasting out a ping to all the sensors at one time. And so it'll just send out a massive sound burst and then wait to see whatever echo it gets out of it. So I don't really care so much as specifically where it came from. It's just if I'm getting an echo from one side or the other, I'll be able to avoid obstacles. I was trying to work on my stereo camera that I had for it, but the Raspberry OS is giving me trouble with getting the camera to work. It works fine in Linux. It works on the Raspberry Pi. If I take using, I'm trying to remember what it's called, FS image or something like that, a program. If I run that first, then I run VLC and try to open it, it fails. But after that, I can grab images out of it. So between VLC and that FS image or whatever the program I was using is command line, the two of them seem to set something up so that the camera works. So it's like one of them sets up half the parameters, the other one sets up the other half. I don't find a lot of information on the camera on the web. And like I say, it works out of the box on Linux on like my laptop.
Pat, I have, as you may have seen, linked up to my online GitHub, and I've been running cameras with Pi successfully for a while, so I can point you to that. And on which Pi are you using, by the way?
I tried it on a 4 and 3 plus.
Okay, you've got a 4-core then. So, because the Pi camera is optimized for multi-core, and if you run it on a Pi Zero, it will run. But if you're doing anything more extensive, it doesn't have any more cores left to do any heavy processing. And I think the output from the camera is natively H.264, and you can post-process that to something else. And I've had a lot of trouble, but what I did was I installed FFmpeg as a library, and I stream it to that, and I can generate an MP4, but I can't do it while the video is running. It's not enough power for that, but I can post-process to MP4 from the native output. And then you can get into VLC.
Yeah, with the Python and OpenCV, I'm able to import the image at a scaled down factor, and that seems to be working pretty good.
Okay.
I haven't done anything with that as yet. I'm in the process of changing it to just my Raspberry Pi camera, but the only one I have currently is a no IR camera. And so all my colors are distorted during the day with all the infrared light that's out there.
So is that a problem for you though? I mean, for what you want to do?
Well, if I'm looking for colors, in this case, orange.
Oh, okay. So you are using colors in your image to do your processing. Okay.
So I've got another camera coming, and hopefully I can get going with that. But 30 days is a lot of time. Is not a lot of time to do work for an outdoor robot competition.
Pat, the camera on the IR one is identical to the regular camera, except for the lack of the IR filter. So what you could either add an IR filter like a camera filter, or you might also look at the fact that in the Pi camera software, you can set up a whole bunch of different, I don't know how many there are, different color schemes. And so like I have a light sensor on my camera for day and night. So when I'm driving around my house, if I go into the kitchen, there's lots of light, I set it up for daylight. And if I drive into the lounge where it's dark, it'll automatically switch to a different mode, and it changes the characteristics of the camera. And there is an IR characteristic that you might swap out of and see if you can get better colors.
Yeah, as a matter of fact, with my street security camera, you can use an IR camera if you have auto white balance setting. It's called the setting called Gray World. That will mostly correct for the color issues that you have with the IR camera.
Okay. I just ordered $30. It'll be here Thursday. I spent it on a camera with an infrared cut filter on it.
I guess the only point I could barrel on it.
Pardon me?
Does it have a 12 millimeter screw barrel?
Yeah, it does.
A lot of those lenses, they're very cheap. You can get them with IR filters built in, and so you can just exchange the different lenses. Banggood's got tons of them.
Yeah, the problem, none of that is quick. The only way I can get it quickly, like Amazon will ship it in a few days if it's in stock.
Yeah.
Otherwise, I'm waiting weeks.
Well, but Pat, that's kind of my point, is that the problem you're having can likely be fixed in software. That it's,
do you have that any of that on your GitHub page?
Yeah. In fact, like I said, well, I don't know about the IR one, but I do have a demonstration of swapping between a night mode and a day mode, and it's just sending a signal to the camera, or to the Pi actually, and saying how to interpret the image. And I think they're like maybe not a dozen, but there's more than a half dozen of these different modes, and you can even tweak them. So you can set the camera. In fact, if you were into it, you could probably set it for a black and white mode that only paid attention to orange, like an orange filter.
Okay.
You'd have to write your own filter to do that, but you could literally, because like my actual pro cam, I've got a Fuji camera for my normal camera, and I can set my Fuji camera to actually have a mode where it's grayscale except for red. You've probably seen the stuff like that. So you could, in theory, write a Pi camera filter that did something exactly like that, which would turn everything in the entire image into grayscale except for a certain range of colors. So that would be an alternative. And you wouldn't have to change the hardware, because like I said, I've even got one sitting here somewhere. But the IR camera is exactly the same hardware except for that little filter. That's the only difference.
Yeah, and right now, for some reason, everybody sells the no IR filter, the no IR camera, and
that's the only one that's in stock.
Yeah. So I managed to find one with a cut infrared cut in it, and I'll I'll use it.
I had to go to the Pi spy camera because I couldn't get the regular camera. So, you know.
Yeah, Murray, you sound like you've done a lot of work with Pi cameras, and I've been trying to use several for my street security camera project. At some point, I may tap your brain on ideas for how to improve performance.
Well, I actually blogged about it. Robots. Robots.org.nz is my blog, and I actually have a blog entry where I don't know if you were here, but I blogged about it like a year ago, where I took where is it? This thing is just a little pink LED inside of a diffuser, and I put a little bit of fuzz in there so it even diffuses it better. This is a regular 5 mil pink LED, but it's a unique color in my outdoor universe. And I put this at 5 meters from my Pi and aimed the Pi camera at it from 5 or 3 meters, anyway, quite a long way. And I could find the pixels, the pink colored pixels of this at a distance and navigate towards it. So yeah, the Pi camera is pretty amazing. You can get in there and, you know, scan pixels and all sorts of stuff. It's pretty cool on the inside.
Well, yeah, right now on my street security camera, I'm using the 12 megapixel high quality Pi camera. And it's got a switchable IR filter in it. It's a little motorized filter where you can swap it. You know, you send a signal, you can swap the filter in or out. So that kind of solves the problem. You know, one size fits all solution. But you know, I've been using the free motion software, and configuring is a real pain because the information that they do have on the Pi camera is it's pretty cursory. And it kind of assumes you know a lot about digital photography. They give you the descriptions of the different modes. The descriptions are really brief, and you go, okay, I wonder what that means. You know? Like I've tried to find explanations of what night mode actually does on the Pi camera, and I can't find any details.
Well, it's out there. I mean, that's how I learned.
I've searched the web high and low for it. I mean, you know, I suspect that what they're doing internally for things like night mode is they're probably giving certain parameters preferences over others. So, for example, I play with shutter speed and exposure time. And if you set it, I believe when you set it in night mode, in certain circumstances, I'm guessing, because I can't find the information anywhere, I'm guessing that it pays attention to the exposure time and probably cuts the shutter speed off at a certain amount if it's not consistent with night mode. I don't know, I'm guessing.
Hey Pat, how do you select the colors of the cone?
Right now for my test, I've been using just RGB, a range of RGB colors.
Okay. Well, even though you don't have you know, a daylight filter to get the colors to appear more true, you can still, you know, try to figure out what the RGB colors are of the cone with the camera that you have, and it should find, even though it may not look orange, it should find that color of the cone.
Yeah, so I've taken a couple still pictures and with my other laptop, and I've been using those to process in my program.
Yeah, it should work. I mean, if you're able to select the color ranges of whatever color the cone appears in the you know, no IR camera, it should work okay, right?
Yeah, well, that's what I'm thinking is that I'm able to pull those colors out, and that was in my living room with a lot of oranges in the wood essentially, because I've got wood floor and a dining room table and cupboards, cabinets behind me, and they're all a brownish with a little tinge of orange in there somewhere.
Yeah.
And I was able to quite successfully single out just the traffic cone.
Yeah.
Or in my case, I used a VisiVest.
Yeah.
Pat, I just posted the link to that blog article, and in the bookcases that are behind me, I had this and this, which are very bright pink guitar pedals sitting on the shelves. And obviously a pink LED did get messed up with those, but if I took these off of the shelves it could find the pink LED, and actually I actually have that in the article. So it can find colors, no problem. And in fact, I turned the resolution of my camera way down. I don't want 12 megapixels to find something if I'm just looking for an XY or actually just a single. In this case, since it's for navigation of the robot, I don't even care about up and down. I only care left or right. So I was just scanning across to see if I could find anything in the vertical of a certain color. And if you're looking orange in a largely green environment, you probably find it.
Yeah, well, it's not. It won't be the end of September in Northern Ontario, so orange outdoors shouldn't be a problem. After the end of September, there's a lot of orange
A lot
outdoors,
of orange out there.
including hunters.
Oh, that's true.
Your robot might start chasing hunters around.
That's it. So, no, everything. The colors are really nice here in the fall. Usually starting around the first week of October. So, it's fantastic.
We have shades of brown in Texas. So. No.
I was wondering, how do you control for level of illumination when you're looking for colors?
It's I'm outdoors. I'm using natural light. So if it's a cloudy day, you work with it. Hopefully you test on cloudy days and sunny days, and see where we go.
Actually, John, that's also in the blog. And what I did is I converted RGB into HSV or whatever the heck it is, and just go on hue. I just went on hue entirely.
Yep.
I was having trouble with that because it seems like some colors were shifted in my RGB or BRG or whatever it is image, and so I was trying to figure out which one was which, how it was switched.
Well, I was using Python, and there's a Python library that allows you to switch between RGB and is it HSV? Yeah.
HSV, yeah.
And yeah, so I just swapped HSV, and you just take the hue value.
I think there might be some other things going on too. Pat, the order of the RGB in some of the programs is, I think it's like VGR or something. Yeah. So that's where you might find that to be a mess. But the simplest from where you are right now is probably to just use OpenCV to do a blob detector, and that should work really well.
Yeah, I'm able to pull up the color, so if I can do that, then I can put the blob detection and just get an X coordinate on it.
Yeah, what I use is a smart sensor called a Pixie Cam that basically all it is a blob detector, and I use that, and it has its own. I put it to its own Arduino processor, a little tiny mini, and all that mini does is say, okay, the field of, where's the center of the blob, and where is, I know how wide the field of view is, and I just say, okay, if it's to the left of the center, then I send a write to the main processor, and if it's the other way, it corrects. So all it does is send feedback of where the center of the blob is. And I have done Pi blob detectors with Pi and OpenCV. I mean, there's a thousand examples on how to do that, and it's pretty good. You don't want to use RGB. You want to use hue and saturation because you'll get it's more insensitive to the color.
Yeah, you can give it a range of hue from one to another, and then you can open the saturation up completely and get all sorts of different shades.
Yeah, so that would be my recommendation on when you do your blob detector, and it shouldn't be too hard with a Pi. And there's other solutions if you didn't want to use a Pi, but you already got a Pi and you might as well use it.
Yeah, I got a Pi, and I'm writing the program in Java with some Arduinos on the side, and
so one of the ideas that to handle light and whatnot that I was trying to do, I don't know if I'll get it this year, but it's one of the things I'm considering. Is okay, you could, if once you establish that you've got a blob, okay, you have a blob, it might be a crappy blob, but you got a blob. Well, then you can adjust your you can adjust your light level on your camera. Okay, the sensitivity, you can adjust it, and you can start trying to maximize blob size. You follow what I'm saying?
Yep.
Or what's included and what's excluded. Yeah.
Yeah. And now, I don't, again, this with enough time, and I don't know if you have, you know, you could also start to add some smarts to it, some AI stuff. But I'm again trying to use a smart sensor called Huffy Lens, I believe, by DF Robot. And what I'm trying to do with that is pick up not only the blob from the pixie, but also the shape from the Huffy Lens. And so that's where I want it to go. I know that's a crappy solution, but time is of a premium to me. And I'll show when it's my turn. I'll show something else that's kind of cool. Okay,
Pat,
that would be the ultimate.
Your your blob, blob finding routines down, or
I've got just the start of it.
okay.
So I haven't gone, I was able to detect it, and that was the first step. And I haven't gone any farther with that because as I was building a brand new robot for this, I can find a blob, but if I can't move a robot, it's not going to help me.
Okay. Are you familiar with Pi image search?
Yeah, I've seen it before.
Okay. He's got thousands of examples of different routines, and one of the more simple ones was blob detection. So he does uses virtual environments to get away from issues with different revisions of like Python and that kind of stuff.
Well, you have to.
Yeah. Anyway, it takes a little time. Well, in my case, it probably takes the most time downloading because I have lousy internet. All of the steps that he'll run you through to do it. But once you do that, it's very reliable. It works great. I've used it quite a bit, and I think probably several other people in the club have too. Stuff from Pi Image Search.
Yeah, I want to say I just did a link on. I just used his link to reinstall OpenCV on my Pi 4.
Yep.
And it step by step it worked. It was none of this crazy. Oh my God, I'm out on step 78, and they don't have that anymore. It actually worked, and so if I can find that link, I'll see. Oh, here it is. I'm gonna link it in, Pat, to. This is how to get OpenCV on your machine in a virtual environment.
Okay. I know I've got OpenCV in, and this time I don't think I compiled it. I think I managed to just download it.
He says that if you're not using one of the proprietary algorithms, that you might as well just download the wheel. And he gives instructions to do. One takes about 5 minutes on a 4, and the other one takes an hour or so. I did the 5-minute one, and it worked great. And one of the things you can do, so, okay, once you get your Pi 4 set up the way you want it, you say, oh my God, I got OpenCV installed. I've got everything. Everything's got good. I know. And now I'm going to go screw it up. What you do is you take another, okay, in my case, I'm using a small SSD card. I don't see if you can see it. Use one of these. These cost about $30. Best deal you can get. They can be natively installed now on a 4 with the latest Raspbian. It's the only way to go.
That's what I'm using.
Okay, so if you got that, then what you do is once you got this guy all set up right, is you put a card back in the slot, card slot, the SD card slot, and you use the SD card copy routine to take this and put it on your new disk. You put it back, and now you have a starting point where if you screw it up, you don't have to go all the way back to ground zero. So I mean, good idea. Or at least it's working for me.
I've done that a couple times where I'll image the hard drive and then keep a backup copy.
Good deal. Yeah. So
I tried to paste a list of instructions that I put together. I'd installed OpenCV on a Raspberry Pi 4 recently, and I wrote down all the instructions. It doesn't seem to be pasting into the chat window correctly. One of the things you got to watch out for when you install OpenCV is don't use sudo if you're for anything other than getting the libraries.
Yeah, so it's interesting when you go through. I found a couple websites that show how to install it, and sometimes they're using sudo and sometimes they're not. And like you say, when you're downloading the libraries, you got to be using sudo to install them in the system. But then there's some pip commands, and if sometimes you use sudo with pip, sometimes you don't. It depends what you're accessing.
Well, it depends on where you want the library installed. If you need to install that library global to the machine, which all of our machines we have a very special case going on here, right? Pretty much the brain of our robot is the whole world. It's not like we have a big server and all these other kind of things out there. So almost everything, I just slam things on here globally, so everything gets access to it, because I don't want that issue, because I'm a big LUA, least user access. And so I'm a big fan of having to do sudo to do everything. And then it constrains me from doing other things. But in this case, where we're at, screw it. You're root. You're the owner. You are God. And you need to play like that. And so that's kind of how I run that. And so if a pip, what happens when you do that pip, as far as I understand it, if you do it as sudo, it's using root's environment to install all the libraries in all the different places it needs to. If you do it as it'll use your environment to do that unless you override that somehow. So either on these devices, the way we have them going, if I was doing it for a commercial project, I would do it totally different. But for our cases that we're using, just become root and just do the damn thing. You know,
well, there is another alternative, and that's to use --user when you do pip.
Yeah, and you can do that. Yes.
And I would have to say that I tend to agree with you that if you're using a Raspberry Pi and you're not using a desktop, there's no danger in ruining the desktop by doing something in a Python install. You can mess up your desktop if you're using a Python desktop, but which Python is used extensively on desktops. But on a headless Pi, I generally do install a lot of my libraries using sudo because you have to. The ones that I've found that you have to, like PSUTL and some of the more fundamental ones that interact with hardware, you have to use sudo, otherwise it can't do its job. Other ones, like a lot of the sensors and stuff, you can do --user and it'll do it into your user space. And just to follow up on this, the whole idea of using virtual environments, VENV, is, as far as I can tell, pretty broken in the Python world. It's supposed to work, and they recommend you use it, but it doesn't always work very well. And in fact, I use
I can tell you if you're following scripts from the internet, you're going to end up putting it in I think they call it the global location. You're going to be putting it in the user location. You're going to be putting it in the version location. There's all these different locations. And then when you go in and say, okay, I know I installed this thing, but it won't find it. Well, you'll go say, well, let me look at all the directories that I should be searching to find it. And it'll be all the directories will be there. They'll still be screwed up. So the only way I found it is using the virtual environments. I strongly suggest, especially if you ever want to do two things on your computer.
Isn't that what like Microconda or whatever is for? Because I remember on the Monkey car, you set that up.
Yeah, Microconda is a version of it, and but for Raspberry Pi, it might not be the one you want to use.
I
You
will
might
tell you,
want to use.
I've been doing a fair amount of Docker here recently, especially on the XOMI that I've been playing on, and that's working really, really well. I mean, it's a little bit wonky for me because I'm like, well, how am I running in this other thing in this container? How is it talking to my hardware down here? And I know it's not in there because the way the whole thing works. And I just got to get past that. That's just me being wonkiness. It does a really good job, especially when this root thing we just come up. There is when you do a Docker run on this, if you do a -- privilege on it, which is, they'll tell you, don't do this unless you're in this situation. It exposes all the ports, all the hardware, all the /dev/ all that stuff gets exposed to it, so you can have access to it. And that's how I'm doing the rover. And yes, I've got some problems that I'll discuss later, but it's got nothing to do with that. But it's really cool on how it's doing everything and going. It makes it where I build this thing up, and I'm like, oh, okay. I change some stuff. I add packages to it. I get to check in the Docker file. And let's say the Docker file blows up. Like I do something terrible and it just all goes to crap. Well, screw it. Docker RM, that image, Docker build, run the image again, and I'm back to where I was in the safe. I was not a big fan of Docker, but as much as I'm using this, the more fan I'm coming of it because of those sorts of that build and workflow. And I'm not afraid to go, I wonder if I had this in there, it could screw everything up. Well, who cares? If it does, I blow away the image and a Docker run again and it rebuilds it for me and I'm back where I was. It's just really nice. It's just really nice. I will tell you though, it was a bit of inertia to get me started going in that. I did it for work. And so once I got past it for work, because, well, you will do Docker. I'm like, okay, I don't know crap about it. You will do Docker. Okay, I did Docker. I'm like, dude, this is cool. Now I'm going to use it for my own stuff and my own hobby and all those sorts of things. Worked out well. I will be quiet. I'm rattling on now.
Doug, the only thing I can say is that in the Python world, there's a lot of broken stuff and like threading. And I, for example, don't use Bash. I use T-shell. And the VN.
I knew I liked you, Mary. I knew I liked you.
Harold, just a minute now.
I knew. I love T-shell. Been using that forever.
Well, that's the thing is if you use T-shell and I use T-shell, unfortunately, VM doesn't work with T-shell. If you're using Bash, it works fine. They have a C shell that doesn't work very well because what it does is it actually, when you create a virtual environment, it creates a whole subdirectory with scripts and everything, and it ties into your shell and alters your path. Of course, that's what it does. But it doesn't work for T-shell. And in fact, I was advised that if I wanted to use T-shell, I would have to write my own pull request, or push request, I mean, and actually modify VM so it would have T-shell support because it's not there. So yeah, it works kind of, but it's a pain. And I'd have to give up using the normal shell that I'm using just to use virtual environment. And even then, it doesn't work very well for a lot of things. So I kind of hope that maybe 5 or 10 years from now, maybe 20 years from now, when we're using Python 7, that it'll all work really well. But right now, it's kind of a pain.
I think the thing you want to absolutely get yourself out of, no matter how you approach this, it sounds like Harold's got a solution. It sounds like you've got a solution too, Rory, is that you don't want to get in this holy, oh crap, I just screwed it up and now I have to re-image the whole goddamn machine. That's what you want to keep yourself out of. And
I'm not having that problem actually. So far, I've been able to figure out which of the Python libraries, like I said, the really fundamental ones like psutil that I have to install with sudo, and I have a setup py file that runs that, and it runs only the ones that can be installed as user, and the rest of them I have to do manually as sudo. But it is that juggling thing where you've got to figure out which ones are which, but I'm not having a trouble anymore. But it did take me a while to work it out.
So are you using a virtual environment for your robot control? So you're not?
I gave up.
Because that's one of the things I looked at is, okay, do I use a virtual environment for my robot? But then, because OpenCV wants possibly different files, do I set up a virtual environment just for OpenCV to end up having a bunch of different virtual environments running on the Raspberry Pi to try to keep software going?
Well, you're doing a whole level of complexity more than I am. And I deliberately try to keep, I'm writing my own Python OS, and it's just a program with a bunch of libraries that I've written. So my Python OS, as it were, is on an install that's I can blow it away and build in like 10 minutes. It's just I don't have anything invested on my Pis anymore. Everything's in GitHub. I flash a new SD card, and I can pull from my GitHub repository and have something running. So if I blew it entirely, it's 10 minutes of fix. I
Yeah.
don't make any investment on a Pi anymore, so it's not a problem.
All the Python scripts I've got are the same thing. I've got a backup copy of them, and it's just a matter of dropping them in place. But then you got to install all the software that goes with them.
And my only point is that your OpenCV thing is a whole level of complexity, and so I think you might have to use virtual environments for that, because it is quite complicated.
So right now I've got it installed, and I specifically went the route of not installing it in a virtual environment.
Huh.
Okay, so nothing so far is in a virtual environment, and everything seems to be playing okay together. Well, that may change, but that's where we will create backups. Like I say, Doug had a really good idea. I haven't done a backup image of that one in a while, so I'll do
whatever you got working.
Yeah,
exactly. I mean, really, I'd use a virtual environment if I could, but I'm able to avoid it. So, and every time I do an install, I get this big warning on the screen, please use a VM. And it's like, okay, I'm just going to ignore you, and hopefully things will just work. And so far, so good.
Yeah, one of the examples with OpenCV, Python transitioned from whatever it was, 2.7 to I think 3.4 and then 3.6. OpenCV went from I think it may have gone from version 2 to 3 to 4 now. I'm not certain. I haven't looked in a while. But especially with OpenCV, a lot of the things were not forward compatible. So, I guess backward compatible. Like if you were using OpenCV 4, let's say, okay, if you wrote things in OpenCV 3, then you switch to 4, you may have issues with your programs. They may not work again. So, and you'd have to modify it. So it kept, the current version of Python, OpenCV, your particular program that you wrote, all in that environment, and you could keep that and run that. And then if you wanted to switch it to the latest version of Python, the latest version of OpenCV, then you could make the changes that you needed to make it work in that environment. And that's his whole thing of why he highly recommends virtual environments, to get around those issues when that next version comes out of something.
Yeah, well, that's the issue. But generally, I don't do a lot of updating on the Pi either. Tend to leave it as static as I can, because if you update all the time, you're asking for trouble. Something is going to break eventually.
Yep.
Agreed. It's my Docker file thing that I just mentioned and rattled on about for minutes.
Just broke. No.
I'll be happy to show that off at some point tonight. I can pull up my screen and show you what a Docker file looks like and what it does, and maybe inspire some evil geniuses out of you.
I think we had John in line after Pat, and then maybe I don't remember anyone else. Then maybe Harold after that, then, or Doug.
I'm happy to get in line. I'll even go last. I don't really care. You know how I am. I don't really. I just wanted to. I will have to hear this.
I've forgotten these other hints, so I think let's go John, Doug, Ray, Harold, and that takes our next, and then Murray. John, Ray, Doug, Harold, Murray. Okay, there we go.
So let's see here if I can get the right image up. So I've added a current sense circuit to my motor driver. Trying to just to reiterate from last time, I was trying to solve the problem of the motor breaking itself or breaking the gearbox if it stalled out. So I've added this current sense amplifier. I managed to get my hands on those before before they got backed up, where you couldn't get them. And a current sense resistor here, and that's that feeds into the PIC microcontroller. So I was playing with it today, and let's see if I can get. So I'm looking at right here with my little logic analyzer that I have, oscilloscope. This is the voltage from the current sense circuit when I first turn on the motor, and all these oscillations you see here are a result of the fact that driving it with PWM. So the idea here is that I'm gonna have to change the code here to figure out where it is I want to kick in the current sense measurements when I first start up, because when you first start up, the current goes up to about this voltage corresponds to about 1.2 amps here at this level, and then of course then it drops off. And down here, this signal here is the one leg of the encoder. So, so you can actually see the motor spinning up in terms of speed as the frequency of the encoder pulses go up. With the current software, you can see this is where I detected overcurrent and then cut it off. And then you can see the motor coasting to a stop. Now, if I put some resistance behind it, that is, if I hold down the motor to try to induce a mechanical stall, then it looks more like this. And you can see the current goes up high, close to an amp, but then only drops off slowly. Oh, excuse me, a little frog in my throat here. So I'm going to have to change the software on the PIC to look for a certain period of time and say, well, if the current's at this level when I first start up for more than X number of milliseconds, then I'll say, okay, we're in a stall condition and we're not going anywhere, and we'll shut it down.
Can you add filtering to that pin, like an RC?
I could, but what I'm going to do instead is I'm actually going to average the A to D converter sampling and average them out. It's easier than changing the hardware.
You might want to look at some digital filters. You can put a low pass digital filter in there.
Yeah, but once again, that involves adding the motor driver board and
it's just software.
Increasing the amount of real estate that I have there. So I figure as long as I get a software solution to work and it can average the signal out, I'll stick with the software solution.
Well, the digital filter is a software solution. You write a filter in your program and it just applies it to the readings. It's a little better than averaging.
Could be better than impulse response filter or.
Well, I'm trying to keep it's a PIC microcontroller, and I've got a limited amount of CPU available. So I'm going to go with simple averaging first. And, if that doesn't do the trick, then I'll explore other options that may include filtering instead. But I would imagine that the filtering algorithm is probably more CPU intensive, and I've got to keep the interrupt service routine for doing those for collecting those samples. I've got to keep that very short.
So Doug, would those be FIRs and ERs, finite impulse response and infinite?
There's just I was thinking just low pass, but again, there's a excellent book on digital filters, and they don't all have to be complex, John. Some of them are pretty simple, just a couple lines of code. I've been a while since I looked that one up. So, but there's a book out there that a guy has that is just, it is eye opener. You read that stuff and you say, wow, where has this been all my life? So, something to look up.
Well, as long as you can do it simply, you do it simply in C. This is the code here that's basically got a timer interrupt that goes off and reads the A to D converter value on the PIC, and it does a sliding window calculation. It averages over about 8 milliseconds. It takes eight samples once every takes one sample every millisecond. And after about 8 milliseconds, it does an average.
That's all in your interrupt?
Yeah, that's all.
Usually you don't want to do any calculations in an interrupt if you can afford it. You want to just get your value and get out again. That way you're ready for the next interrupt. If this one means you're in your interrupt, how many milliseconds? You said 8 milliseconds. Surely not that. You're talking microseconds, maybe microseconds.
No, I'm saying this interrupt is designed to go off to fire every millisecond, once a millisecond.
Once a millisecond. Okay. Okay. No.
So anyway, yeah, it's
Depends on the processor speed. I mean,
32 megahertz on the processor.
oh. Yeah. What is it? It's a 2-bit machine?
It's a 16-bit microcontroller.
Oh, okay.
I guess I would argue that you should try to see if you can pull some of that stuff out into the loop somewhere. But if if it's working for you, it's working for you. You don't argue with success.
Well, these are good ideas, and certainly I'm always one that when I'm looking at my code, I'm always looking for ways to improve things and improve performance. So basically what I'll do is I'll get something working, or mostly working, and then as I look through the code to solve certain problems, I'll always look for I can optimize that, I can remove that, and I'll see if I can pull any of the code out of the ISR.
Yeah.
Is it a good rule of thumb?
Yeah.
Well, that's all I had.
Okay, pretty cool. Thanks. Making progress. I think Doug, you were next, and then Ray on board.
Okay, well, I've got a lot of stuff, guys. So let me start off with something. I'll hit with a big one here. All right, give me a little second. I got to move my camera. This is not the top. I'm not showing you the top of my head for purpose. There's you guys. And this is a oak, note D. And what you're seeing, well, if I can get it on there. Come on, guy. Okay, right there. This is mapping distances.
Depth, yeah.
All right. So like if you can see my hand coming into it, see how it got red?
Yep.
Okay. And it's achieving 21 frames per second with it looks like pretty good resolution, and also running an RGB picture in the corner with doing object. You can see a block. It's seeing me as a person, so it's identifying me as a person. So it's doing some AI. It's doing AI at the same time. So anyway, this is kind of cool.
Is it hot to the touch?
No, it actually. I read that up again, and the current's really not that bad. Okay. This is running off a Pi. So you would probably want to. But anyway, it's pretty impressive. I don't think I'll get to use it this August, but
Skynet, here we come.
Yeah, a little later on maybe. I'll probably have a more crappy solution for August. But that's one thing. We kind of get that. Okay, and then I'm going to beat Murray to it. Whoa! Yeah. Yes, Carl's presentation that he made at the talk was very, very enlightening and eye-opening. So I definitely wanted to try a few of these, and maybe one straight one here for just reference. So
just make it so it has one more light LED than his, and then you're okay.
No, actually, what I was trying to do was make sure that they were divisible by 4.
Mm-hmm.
All right, so that you can do compass stuff with them.
Yeah.
Now, the other thing was, today, if I can find it, I'm going to do a share here. See. Oh, is that now? Okay. Share. All right. No, not that one. This one. Rev introduced this guy, all right, which is a real high power hub, and that's not what I wanted to show. They also did this, which might be very usable fuses for some of our robots.
Circuit breakers, then it says.
Yeah, they're
auto
circuit breakers, auto
Yeah.
resetting circuit breakers. So anyway, you know, we probably wouldn't need anything more than the 10 amp one, but even so, that if I had a LiPo battery on there for $5, that might be actually a really nice thing. And they haven't really said anything about it, but I wouldn't be surprised if they also have a circuit breaker holder product. And then this part here is like $200, so that's a little, not sure we're going to be really interested. I mean, this would probably be something that
so those circuit breakers don't plug
Kareem,
in?
yeah, that's what that is. They see those two slots.
Yeah.
That's where
Okay.
the circuit breaker goes. So I mean, this would be for something Kareem would probably want, but I'm not sure we would want that on our part. Okay, and
So is that a voltmeter or a current meter on there as well?
it says battery voltage.
Battery voltage. Okay, so voltmeter.
Okay, so it's monitoring the battery voltage. And my understanding is it's all connected with CAN bus, which is something that I would love to have when I get a real robot. I'm going to have CAN bus working on it. These are the low current ones, and I don't know. They probably just use they probably use fuses or something, and these use the circuit breakers.
Hey, Doug, quick question. I found that web page and these circuit breakers. Do you think that those are just automotive ones that have been rebranded by Rev Robotics, or are they?
They might be. They might be. But Rev is pretty good. So I mean, my thought about it is, these aren't fuses now. These are circuit breakers.
Right.
So, you know, I don't know what an automotive circuit breaker would cost, but I would imagine it'd be more than $5.
Agreed. I just wonder if there's a socket for these.
Well, that's what I'm saying is I'm sure that they will have a socket. I just don't know. I don't know. I haven't. This was really. I just saw the announcement today, so I don't know. Let's see if I can find this other thing I wanted to show.
It's not even on sale yet.
No.
Yeah, it's not even on sale. But anyways, something to look at. And let's see.
Fuses are pretty commonly used in the FRC world. So this is not the only manufacturer that produces them, but they're now competing with the previous provider of these kinds of things for this power distribution module. It looks interesting, but I don't know if they're intending to provide individual sockets for them.
Well, you know, maybe there's an opportunity. Okay, now here's
standard automotive fuses.
yeah.
I'm gonna put a link in the chat in a second. I just found one for $6.
And they also look like they've just got regular blades on them, so you could probably just get a push connectors, push onto the bottom, I think.
I gotta admit that the one thing that I would like to have seen them do is a 5 amp one. That would have covered even tiny robots, you know. But 10 amps would be definitely. Oh my gosh, I got a short, and I got to stop my LiPo battery from self-destructing. But anyway,
The link I put in has options 5, 6, 7.5, 10, 15, 20, 25, and 30. So pick your amps.
Cool.
$6 a piece.
Sounds good.
Automotive T1 plug.
Right.
Cool.
Anyway, I hadn't seen it before. I saw that and I thought that was cool. So here's the next thing. you all know I've been screwing with this little robot base. So here it is doing some waypoint navigation. And at this time, I hadn't had I didn't have the display working. I've now got that working. So the display now would be showing you X, Y location and heading error.
Hey,
So,
speaking of which, did anybody live close to where that house exploded in Plano?
no, not that I know of.
Okay.
It exploded? Where?
Yeah, I think it was a gas
In
leak.
Plano.
Yeah, I'm about 10 blocks away.
Oh, are you? Yeah.
And
Is this
shook my
straight
house.
up odometry?
No, it's odometry with IMU. So that was just that was before I got going with the thing in August. I was trying to get that little robot going because I wanted to test out how the wheels handled over time with those little yellow motors. And I fought it and fought it and fought it and fought it. And all of a sudden I found the error. I was bringing some code over that was legacy code, and I just, every time I looked at it, I didn't see it. And so I was telling it, so what the problem was, I actually had it configured for one of the Pololu 25 millimeter motors. And that's what I couldn't figure out. Well, I'd change stuff and it wouldn't change. And the reason was because I wasn't really changing stuff because it was being overwritten by this other file. But anyway, having gotten that finished, so the next thing brings me up to I now have my 3 sensors that you saw on that robot working very well.
Next thing, real quick.
Yeah.
You had the IMU on that robot. Was that the BN055 or
Yeah,
80?
it's 055.
Okay.
Yeah.
Yeah, that's what I was going to ask about.
Let's see.
Kelly,
So-
you were raising your hand. Was that about the house in Plano vicinity, or was that another comment?
It was, my house shook and I thought a tree fell on my roof, and I went outside to look and didn't see anything. And about 30 minutes later, the helicopters show up taking pictures of that exploded house for the news.
Oh, wow. So you were close to it then, huh?
And within walking distance.
Ooh.
Wow.
Yeah,
Shook the
that
house,
looks
huh?
Yeah.
That's pretty big. Okay.
It actually blew over a tree. Wow. Ooh.
So the last question that I wanted to have that was a discussion on was strategy for obstacle avoidance. Okay, assuming you have, let me show you. If assuming you have this type of sensor, so you got front and left and right 15 degrees. Now I might add additional sensors, but let's start off with this because it gets complex enough. The question becomes, what's the best obstacle avoidance technique? And, I was like to hear everybody's opinion on this. My first thought was kind of along this particular method. Okay, first thing you check is the obstacle closer than your waypoint? Because if it's behind your waypoint, you don't really care. Then you decide, if it is, then you decide which way you're going to turn, and that would you would use your 2 side sensors and decide, okay, one shows it to be a little closer and one's a little further away, so I'm going to turn the way it's further away. So it starts turning, and you would just continue to turn until the one that was close now doesn't see anything. All right, so you've cleared the obstacle. Then at that point, you would go ahead and set a temporary waypoint. And all that means is I'll go straight for some distance, 6 inches, 8 inches, a foot, whatever it is. Assuming I'm now clear, I don't have an obstacle in front of me. If I have an obstacle in front of me after I've turned and cleared the side one, it will return. Okay. And then after you've set your temporary waypoint, you go to that temporary waypoint. And then once you hit that waypoint, you attempt to return to your original waypoint. Now, if you see an obstacle again, then you go back through the whole rigmarole. Now, that was the way I was going to approach it. I'd like to hear how, I was hoping David would be on, but I'd like to hear how the other guys are thinking about obstacle avoidance. How do you guys plan to do it? Or how do you do it? Any input?
I think Dave sent an email out on RoboMagellan strategies. I didn't read it, but if you were looking for an explanation from Dave, it may be in that email.
I didn't see that. Okay, is that on the list? Did he send it to the list?
It was on the D list, but I mean, that whole presentation that he gave on outdoor rovers last month, I was really inspired by it personally. I haven't gotten to either the waypoints or obstacles really. I've just been playing with IMU and Mecanum wheels, but I very much liked the approach that David was describing and was thinking to plagiarize wildly.
Oh, I would too.
Spin here and there.
I mean, yeah, no question about it.
I mean,
Dave's been working at this a lot longer than I have.
He's figured out a lot of stuff, and he's got it in a really nice organized manner.
Mm-hmm. But I was wondering if the approach that I just mentioned. Okay, so basically you say there's an obstacle in front of my waypoint. I turn towards the sensor that's got the longest distance. It's when the sensor on the other side clears, then I go forward a certain distance, and then I recheck to go back towards my waypoint. That's the basic idea. And
So it sounds a little bit like you're trying to be very procedural and top down and you're thinking about it. And I think that David might, if we can all channel David at the moment, without words in his mouth, he might try to find the low level behavior that's associated with each individual sensor and see what behavior, what higher level behaviors sort of just come out of that naturally. And only if he's stuck at that point would he like try to put in some sort of conditional logic that would try to provide an overall strategy over it. I'm not suggesting that's the way to go.
You still have to react to when you see something, though. And
well, that's just it. I think that the behavior the behavior you're looking for emerges when you're just taking care of the lower level things, like a particular ultrasonic sensor that is configured for obstacle detection. If it's going to just want to steer the robot away from it, what happens when you have multiple of those configured together? What behavior emerges? And it's almost like some of those things will be naturally solved for you without having to explicitly code for each instance. And you don't really find that out until you start playing with it and experimenting with it.
Yeah, I hear you. That's I guess what I'm saying is I was just curious. Okay, if you see something in front of you, ultimately you have to turn away from it.
Yes, but there could be different zones of aversion, if you like.
I mean, if you're right on top of something, it's more likely to have an immediate impact than something further away, right?
Mm-hmm.
So that's where I really like on Dave's sensor design, which he seemed to get at in an empirical, iterative thing over many cycles. You know, he had these really in close ones that would carry a certain zone, then further out ones for different zone, then the much further out ones. And then it struck me that in how you approach the avoidance behaviors, they kind of mapped naturally to kind of like what expected mode you're in. Are you trying to escape something? You're trying to go somewhere, and then they, I think, to my way of understanding, they map towards like, is this thing more important than the other at this time?
Well, I can't. I'm probably the person who is least likely to want to speak for David at this point, considering we seem to have a disagreement, although I don't know that we do. But I do think Kareem has very accurately characterized from my perspective what David's approach would be, which is to keep everything as low as possible in terms of the non-ballistic, non-long-term thinking, that he's running every decision on a 20 hertz loop or a 25 hertz loop. And that is at the point at which there's no long-term thinking. Basically, the emergent behavior of avoiding something comes out of those very, very small iterative changes and prioritization at that level. There's no higher level, like, I'm going to go around this object. He basically, as far as I understand, the robot goes around the object by making a whole lot of 20 or 25 hertz decisions.
Yeah, so the way you're saying it, Murray, and I understand that, and I think what he's saying is, okay, you see a waypoint, you know, it's in front of your waypoint. I mean, you have an obstacle in front of your waypoint. When you first detect it, you start adjusting it to go, say, slightly to the left or slightly to the right. And then if it continues to, as you approach it, if it now hits your second zone of sensors, you increase your rate of turn. And if it gets right up to you and you're you know, oh my God, I'm going to hit, then you do something drastic. You might even go into a backup mode, which might be the bumper reaction.
Line following.
Or yeah,
Following. I'm assuming wall following.
Yeah, that the wall following might be an example too. Yeah, Dave, I guess you can always think of that it, you know, he had the two 45-degree sensors that he was using for white wall following. So the one I've got's only got 15 degrees. So 45 out would be a different perspective than the 215. So you could base a strategy. That would be another zone. So you could base another reaction based off of that zone. I agree with you. That's a good one. Yeah, and another one would be one that's straight off on each side. So, you know, at first you don't think, well, why would I be worried about something on the side? But you might, if you were in a trap, you might be worried about it.
Well, the thing that he showed, that David showed, was where if your tail is pointed at the
opening of a U
at the waypoint. If there's obstacle between you and the waypoint, and you're facing away from the waypoint, then you're in a singularity trap. Switch to wall following.
Yeah.
So one of my
The
questions
right hand
was,
rule or the left hand rule till you get out, and then the waypoint's in front of you again.
so one of my questions on that note was, how far will you follow the wrong direction, follow a wall in the wrong direction before giving up on it?
Well,
Because when David got to the cul-de-sac in his video, he could turn out and go to the left or turn out and go to the right. And if, you know, it was 100 feet on the right side, but he turned around and followed the left side, sorry, the right side of the robot as he went out the cul-de-sac, and he followed that around for miles.
Yeah, what he does is he just arbitrarily says, if I'm wall following, I'm going to go to the right, or I'm always going to go to the left. I never look to see which is more optimal.
Because you can't, in a lot of ways, you can't tell, right? So he's relying on the idea that in many, many, many cases, from what he's saying, it's a well-known thing apparently that if you're stuck in a dark room, you don't know your way out, just put your hand on a wall and follow it. Sooner or later, it might be a lot later, but sooner or later you'll find your way out, right?
So yeah, so it could have been the 100-foot path to the target, or it could have been the 3,000-foot path to the target, but he arbitrarily chose to do a U-turn and follow the right side and go around the building.
Right,
Sure, and
right.
But
In other
there are
words,
certain, but
They
Carl,
call that the right hand rule, and that works for most things in mazes and all that kind of stuff, unless the designer knows you're about to do the right hand rule, and then they can do some funky stuff that will mess that up really bad.
Yeah.
I mean, if you think about it, the turning left might give you the 100-foot solution, and turning right, like you said, Pat, might be following the Great, Wall of China all the way around the entire country, and there's no way to know.
That's what I'm wondering. Is there a point where you say, okay, I give up, let's turn around and follow it the other way?
Well, David has a solution for that, actually, and that he even talks about that in some of his videos and online stuff, which is he has a virtual box around like a boundary. And so when he had one of his videos where his robot goes out the hallway, it just starts heading down the hallway. And then all of a sudden it just stops because it's got to the limit, its bounds, its virtual boundary. I think it's a virtual sensor, and says, that's as far as I'm going to go. So what you could do is say, I will not let my robot go more than 1,000 feet in any direction from origin, and that's the bounds. So he kind of does do that already.
And then there's another way you could do it too. Like at least when I'm navigating in an unfamiliar place and it's hard to look at the map, I have a sense for how far away the thing is that I'm aiming for, and I know about how long it should take. And there's this little watchdog in the back of my brain that says, we should have turned left within about 20 minutes ago, so we should really pull over and look at the map again.
Yeah, I do that too, except I look for a part, I look for a location or something on the map when we did map. The GPS is just whining at me now, but about when I know I've gone too far. I don't know if I've gone far enough, but I know if I get to this point, I've gone too far.
Right.
And explaining that concept to the wife in the dark when we're driving in the rain that was lots of fun. But anyway, why am I looking for that? Because we okay. But I think all you folks get the idea.
But I think, Carl, you've pointed out something that's quite true, which is that women's range for maybe we should stop and look is a lot shorter than men's. We'll drive for days because we're done.
But you could code that, right? You could have
a male robot will go forever until it finally says, maybe I've gone too far.
The monster robot goes around the Great Wall of China.
It'll have explored all of China, which is another side benefit.
So for
I
now,
think
forevermore,
Kelly raised his hand, so
anybody who builds a robot in this club now has to designate whether it's male or female, right?
Well, I think we've even proven that if Christopher Columbus had been a woman, he never would have discovered America, right? He was looking for India, right?
Back to Spain, yeah, Portugal.
Yeah.
You're probably found India.
Mary, you're talking. He was looking for a mail order bride that long ago. Is that what you just said?
guys. Okay. Yeah, I think Kelly, you were gonna sneak in there with something again.
Yeah, Doug was asking about navigating or negotiating these waypoints and everything. I was thinking in terms of having an orange cone that's an object you can't really run over it. I mean, you can head straight for it. When you get there, you kind of have to do something, go left or right. And I was thinking that it kind of reminded me of sailing a little bit. If you're in sailboat racing, you have waypoints that are set, and there's a buoy there that's a mile away. You can't see it. And so you sail straight for that waypoint. But when you get to that buoy, you got to swing a little bit right before you start turning left to go around the buoy. So it's like there's an arc type motion almost at the waypoint that you need to do if you're trying to avoid a cone or a buoy. So I was thinking it would probably work pretty good for a robot too, to head straight for it until the cone is a certain size where you recognize, oh, it's 12 inches away. I have to start a curving path to avoid a collision, and then head out to the next waypoint and head straight for it until I get within a circling range or a turning range, and then do the same thing again. And there's a couple of methods they use in sailing that might work in robotics too, where if you're on a circular path and you look and you see an object at a certain angle, like 20 degrees off your port, and you're turning and it's not changing, that means you're probably have got a pretty good circular point around you're making a circle around that point, if it's not changing position. And so there's a couple of those sailing concepts that might work pretty good for a robotic navigation.
It's a great insight, Kelly. I like that.
Mm.
Yeah, my only sailing experience was on a guy that I used to work with had a 40-foot Marconi rigged sloop, and it had, so big it had a wheel, didn't have just a rudder, and you would turn the wheel and nothing would happen, so you turn the wheel some more and still nothing would happen. So you turn it some more, and then you go into irons, and then it would take like 5 minutes to get the thing, to drift back around so it would catch the wind again. It was impossible. So just like no feedback on the wheel at all. So.
Well, I used to sail race in Northern California, so I'm familiar with the rules as Kelly was talking about. And I think the idea of, and you have to turn a certain port or starboard around a buoy kind of thing when you're in a regatta, there's rules for that. And I really like the idea of saying, you're coming up on a waypoint, you can't hit it. And it's not a dot on the ground. It's actually an object you've got to go around. It's a great idea. I think that's really, in robot challenges, it would be almost really cool to maybe adopt some of these sailboat rules, because that's how regattas work, right?
Yeah, and they have red buoys and green buoys too that tell you which side you're supposed to go on. It'd be another interesting tool.
Yeah, that's great.
Yeah, but one of the rules of this contest is you have to touch the cone, right?
Mm. So you don't have
right
to. To get the most points, you have to touch the cone.
Right.
But Ray, that's kind of what I'm getting at is that we could actually, I think I like Kelly's idea, is that you don't have to touch the cone. You have to go around the cone in a certain direction, clockwise or counterclockwise. And that would mean that you would have to come up with a way to get around a cone without banging into it.
It's a barrel race.
It's a more challenging way to do it, but it's actually more elegant in a way.
Okay, so who's going to build the first sailing bot in this club?
There you go.
There you go.
I think HoverSim's got the best chance.
I don't know. I think no, not NASA, but NOAA. NOAA's already done it. They've got autonomous sailboats that'll go, drones that'll go across the ocean just on wind power.
Wow.
I saw that not too long ago. Okay, cool.
Well, Doug, I don't know if we answered your question there about.
I did get. I got some interesting insights. Add them to my internal discussion. Who knows?
Cool.
Sounds like more sensors. More sensors.
Keep it simple. Make the ones you have work first, right?
Yeah. Well, that was the idea, but
yeah.
Complex decision trees. There you go.
Right. Yeah, I'm still playing. I was real intrigued by Pat's. I don't know if he's here anymore. Yeah, he's out. But he had that ultrasonic, semicircle. Mm-hmm. Pat, I'm talking about your thing. Yeah.
He had like 6 of them.
Yeah, I don't think I want to quite go that far, but David would argue you need at least 2. And it might be worthwhile. It'd be interesting to see if you were going to do your wall following sensors at 45 and maybe 2 in the front. Yeah. Yeah, I like that. The fact that it's going, that's going to take a lot of current there, guy. You're going to have to feed it its own power.
It's
when you pop all 6 of those together, it's going to go cool.
Yeah, it'll give it a little boost of power. So I've got a 5 feeding everything.
It looks really good. I really would be interested in finding out when do you think you're going to be able to test it? I mean, I don't want to put you on the spot or anything, but when does that fit in your August schedule?
That fits in prior to August, so I've got to get this mounted on the mast. And I don't know if you can see, I put the pins facing backwards, and I've got to build a wiring harness to plug them all in and tie them to the Pi. So I mounted the Pi today, and I used just a couple of the I/O pins I'm not going to use, and just made a little copper loop, and was able to screw it into the sinter plastic to hold up the Nano. So I'll mark the pin locations. I'll drill through the plastic, and I'll pass the wire through there. It'll be permanently mounted in there, and then just tie everything to a harness.
Yeah, I like the idea of making it a smart sensor so that you just communicate with the big one.
Yeah, so I think I'm going to tie a servo into it as well, and I'm going to probably have a servo actually for the camera. So with David's idea of keeping the camera level. So
well, I did mention a couple of weeks ago that I was surprised at how important that can be.
Yeah,
more than you would initially think. You know, you'd say, it's not that big a deal. But when you're going down like this, it's a big deal.
Yeah, and that's it. If there's a ditch or something, or you're climbing over an obstacle, and you're looking at the sky, well, it doesn't tell you that there's something on the other side of the obstacle.
Yeah. I don't know if mine will be that sophisticated this year, but.
Well, there's the model, the first step, right? Let's see how far we can go. Can we even find the other orange cone?
Yeah. Okay. Now, just so everybody knows, Pat has submitted his location, and the DPRG groans have looked around, and we found him a course, so he's good. He's good to go. When on the day of the contest, we're gonna send him his coordinates, and he'll be ready.
Yeah, so I've been working on that, working with GPS coordinates, because I'm assuming you're going to drop some pins on a Google map and give me the coordinates. So I've got a routine where I can, in Python, where I can take the GPS coordinates and figure out distance and direction. And from that, I can extrapolate to an XY map.
Cool.
So that my odometry can come into play and kick into it, rather than just relying on a GPS for position.
Pat, is this where we ask whether you're happy that you retired so you can sit and play like this now?
Well, that's I went on vacation last week, and my vacation every afternoon consisted of programming. So I got some fishing in. I picked up 5 or 6 largemouth bass and did some fishing, played some games with the girls and my wife. But yeah, my life right now is this contest.
That's phenomenal. I'm jealous.
That, and then, well, we're still playing with possibilities for part-time work, and I might have wrangled myself into a part-time job.
There you go.
So.
Okay, so Doug, did you have more items from your?
No, I think that was the last one I had on my list. So.
Okay. I think then Ray, I think you might have been next in line.
Yeah. I have been playing around. I have the one of the cutie pies. It's a little 1, 2, 3, 4, 5, 6, 7, 14-bit processor. It's the SAMD 21. And I got one of the B&O 085s, and I've been playing around with it. Carl, I wanted to ask you, which one were you using when you did, your test for like drift and that kind of stuff? Was it
No, it's a 055.
B&O,
the Bosch B&O 055.
Okay, and you said you're using sensor fusion mode with the accelerometer and gyro, right? Not the magnetometer.
Well, I've tried it both ways with the accelerometer and gyro, and I've tried it with the accelerometer, gyro, and magnetometer, AGM. And at the moment, I just decided to run with AGM mode until I'm just going to leave it in that way until my next step really on that rabbit hole is to make a much more careful attempt to calibrate the thing and store the calibration values. Because I did a really crude handheld I think it was the sloppiest calibration you could do and still have it think it was calibrated.
Oh, okay.
So I want to redo it a lot better, and then see if that improves the robustness. Because like I was showing in the Seattle Robothon, on the B&O 055, what I've observed is that running it in the sensor fusion mode, it takes the outputs of accelerometer, gyroscope, magnetometer, and it has some in the background algorithm that keeps track on each sensor independently and knows whether it's operating within what it'll call calibrated parameters. And then in the fusion mode, it attempts to combine knowledge of those three. And if it's calibrated, then it says all three are calibrated, so the whole system's calibrated. And what I've observed is that the magnetometer will just fall out of calibration now and then, and you have to flip the thing over to bring it back into calibration. But I'm wondering if some of that has to do with, like I said, initialization again, right, with the default calibration. But then there's another, I had a long discussion with David after one of our meetings recently, and he was explaining how the magnetic flux from the poles of the Earth have a different angle into the ground as you go
inclination.
South, and that what a lot of the calibration routines are doing inside of these things is somehow taking into account the angle of those flux lines, because when you have a 3-axis in each of 3 sensors, it uses the accelerometer 9.8 meters per second, which is easy to measure, and it uses that to offset the angle of all the others. So anyhow, the bottom line is that the jury's out on the B&O 55, Ray. All I can say is that, like I was mentioning to David after the call, I think, is that I've seen it when the magnetometer goes out of cal, and it's no problem. The sensor fusion, even though the system sensor fusion is out of cal, still the gyroscope and accelerometer are in cal, and I don't, just by the eyeball, I don't notice a difference in the heading error. So it knows the magnetometer's out of cal, it just says, fine, I'll throw it away. Other times, and that's 9 times out of 10, it doesn't matter. On the 10th time, though, when it goes out of cal, it is loopy. It is totally lost in terms of direction.
Yeah. As far as drift, were you seeing like tenths of a degree or whole degrees or?
I have, and I forget who it was that was on the call last week that was going to go look at this, but the drift is a funny thing in fusion mode, because like I took my hover sim and sat it on the table over 24 hours, and I had the display showing to the nearest tenth of a degree. In over 24 hours, it didn't change ever. I looked at it, it never changed.
Yeah.
But there was also no motion. And then I noticed that as soon as I put it on that Lazy Susan, which is really smooth Lazy Susan, it's not crunchy, it's not mechanical wheel vibration, it's not crunchy, it's really smooth. You just have to turn it 5-10 degrees and put it back, and all of a sudden it's off by 1 or 2 degrees.
Okay, yeah.
So my presumption is that in the fusion mode, it's got some kind of, in the background, it's always running. It's always trying to auto calibrate and recalibrate the sensors. And I believe that it must have some, and it's combining knowledge of the different sensors, right? So I think what it's doing is using the accelerometer, for example, to say, hey, there's no vibration. If there's no vibration, the thing must be still. If the thing is still, any motion coming out of the gyro probably is drift. So I'll get rid of it and make it 0.
Yeah.
But as soon as I see vibration, now I can't just subtract that 0. So I have to have some other way of drift. And I think that's where I think I've seen issues, because as soon as I start to drive it around, I mean, it loses. It's not terrible. It's within a few degrees by my eyeball, but there is drift in there. And that's why I think, for all of those reasons, the magnetometer going out of cal and the drift that creeps in, I'm thinking that a more robust initial calibration, probably a better, less flexible than a duct taped pill bottle mount to the platform.
Yeah.
I think all those things together might help it.
Okay. Yeah, I was noticing with this one that Well, I think, it's not nailed down to anything. And, so I'm just kind of moving it around on my notebook, and I made some initial marks, and then, would move it around and then try to place it, back on the initial marks for 0-degree heading. And it would be a little bit off, but I'm sure I'm twisting it probably much faster than the robot platform would ever rotate. So, I may be, it may be too much of a jump, and then it it starts to drift a little, but kind of like you said, not 10 degrees, more like 1 or 2 degrees.
Yeah, it's enough to be annoying.
Yeah.
But best recommendation, the best thing I ever did in that was to go get the Adafruit library and just copy it that stores calibration values. So,
Okay. Yeah.
so when I calibrate it, I just run it's a 20 line Arduino file. I run that, it fires up the display, and I step it through its calibration paces. And
Right.
when it's done, it saves it. And then when I fire up my main code, it reads that whatever value is in the EEPROM, whatever it is. So
Yeah. Okay. Yeah, I've used that too, and yeah, I would actually pick up my robot and rotate it in 3 directions before I started something.
but it was a really, really helpful thing to do. Super helpful.
Okay. All right. Yeah, I was trying
Well,
to integrate that onto one of the lawnmower platforms, and I was, that's a horrible environment. It's vibration, and
Yeah. EMI in the works.
yeah, EMI from a spark plug and from motors, and yeah. So I was just trying to see, in a quiet environment, would it actually work? And I've had it on a wheelchair platform, just kind of going a certain distance, trying to do a 180, come back, and then try to trace that same path. And I know after like maybe 4 or 5 passes, it's off a degree or 2. And and I was turning very slowly, and no jerky movements at all, but as smooth as I could possibly turn it.
Yep.
Because I thought maybe if it did have like a sharp impulse in a turn, it may exceed one of the ranges of one of the 3, and go into saturation or something. But yeah, so I guess that may be all you can get out of the BNOs. Maybe just a couple degrees of.
It may be. Well, that was another thing I forgot to mention on the calibration is that, I mean, when I did it, it was in January, but it was in Pittsburgh, Pennsylvania, which is 500 miles to the north.
Mm-hmm.
So that difference in the angle of flux lines could very well be giving me grief.
Magnetic declination. That's
Yeah.
the root of all evil. Yeah. Okay.
And Doug just posted a link on magnetic calibration in the chat here. So.
Oh, he did. Okay.
Yeah.
So, Carl, I guess. Oh, go ahead.
Go ahead. I was thinking that wouldn't make that much of a difference, the declination. I mean, yeah, okay, maybe it's a few degrees difference in Pennsylvania versus Texas, but the thing's supposed to be able to figure that out anyway, I mean, it does.
Well, think about it. If it's on your wrist or your phone, right? It's moving around all the time. So it's got plenty of data to go kind of deduce where 0 is at any given time, because you keep flipping back and forth, right? But if you've got a 4-wheel robot that's always horizontal, it's never able to sample the other dimensions.
Yeah, that's true. It's kind of working in a plane.
It's always in the same plane, right?
Yeah, right.
So any drifts that accumulate over time math error is going to add up, right? 0 is not really 0.
Yeah. There's
Chris, that's what we need to hear from, because Chris was going to dig into this since the last meeting, and we haven't heard from him.
Okay.
And John's raised his hand. This is cool. We found the raise hand button now.
Well, yeah. Well, not everybody has it, I think. a different
They don't?
topic, and Murray's going to hate this topic. I've been trying to waterproof this enclosure for my outdoor my security camera, and I've gone through several iterations of this. The first iteration of it was I just 3D printed the box, and then wherever there's a seam, like a cover that goes on, I've been putting clear silicone sealant in that seam. Well, that leaked pretty quickly within a day or two, and when lens started fogging. So then I went and I basically painted the entire outside of this box with epoxy resin. And it didn't exactly apply smoothly in all cases, but I think I had everything covered. And that lasted about a week and a half, and then it leaked and fogged again. So, I'm kind of trying out the next iteration, which is I've got some silicone modified conformal coating in a spray can, which is pretty nasty stuff. So I have to wait until it's not windy where I can apply it outside. And I'm gonna spray the inside of the enclosure as well as the outside of the enclosure in all these places, and see if that does any better. It's just been really frustrating that everything I've done so far, including limiting the number of openings, making sure that every opening has silicone sealant around it, and then coating the outside, it's failed every time so far.
Well,
So,
John, the only suggestion I would have is that I think you're trying to seal the wrong thing. That I know that you don't want to make a big change to your design at this point, but I was just kind of pointing at my letterbox robot, and it's just a big wooden box, and it's relatively well sealed, but the actual Raspberry Pi is in an almost entirely waterproof commercial box with an O-ring and everything. And so if you could somehow figure out how to use one of those commercial boxes with a gasket, what you'd be doing is having a box around that gets most of the water off, and then the box on the inside would just never leak.
yeah, well, it's difficult to find a box that has all the right size openings and holes and whatever. Why I'm 3D printing, because I can produce exactly the dimensions of the box with the right holes and attachments on it. So anyway, I'm just wondering if anybody had experience with sealing or waterproofing 3D printed boxes for outdoor use.
One option that you have for that device is the camera lenses particularly get chilled in the wind pretty easily and makes them susceptible to the fogging. So if you take a 5-volt fan and put it near your single board computer, your Raspberry, and blow that air through a little tube on the lens, you can actually make the lens a little warmer than the ambient temperature of the air, and you'll be less susceptible to it fogging.
So you're just basically saying that's I've heard somebody else say that too, is just make sure the camera section is warmer than the rest of the box.
Yes.
Well, there's another thing you could do, which we did when I worked back in the defense industry. So, I mean, you'd have the silicon seal around all of the joints and seams, but then you'd also have a valve, so you'd fill the thing with nitrogen, and you'd have some desiccant, and you'd have some desiccant inside, right? So you can go get desiccant for a gun safe or something. So you put a desiccant in there, then you evacuate the air, you put in something that doesn't have moisture in it, and now there's nothing to fog on the inside. Yeah, you might need a little more desiccant than that, Murray.
Well,
but
yeah, I actually put desiccant in the box at one point. That didn't help. It eventually caught up with that and leaked again. So,
well, that's the question, right? Did it leak, or was it just condensing?
Condensing on the, I've got this
On the inside.
Got this plate. Yeah, it would condense on the back of this of this.
On the inside, so you still had, so the air wasn't dry. So you got to make the air dry on the inside after you seal it.
Well, no, it was clear. It wasn't. It didn't have to do with temperature. It had to do with the amount of time that it was sitting outdoors in the pouring rain. Because it went for a week or more, where the temperature and the outdoor humidity was pretty much the same. And it wasn't until it rained real hard that it started fogging inside here. So I've actually seen one guy suggest, well, just you don't have to have the box entirely closed, just have an opening on the bottom, and any moisture that, you know, and then I think he said the same thing about make sure that the camera is warm and the rest gets out. And eventually, you know, that would keep it from fogging.
Yeah, the thing is that it's virtually impossible to make something sufficiently hermetic that you're not going to get water in it. So the idea, in fact, if you look at houses, that's why they've got weep holes in the brick, because it's going to get water in somehow. Just give it a place to get out.
Let it breathe.
Yeah, well, I'll keep slowly working on it.
Yeah, I was told by my insurance agent that when my basement flooded for the third time this last weekend, that as long as the water was getting out of the house, it was okay.
Yeah, the thing is because the way I've got this box segmented, there's actually 3 segments. You know, talk about getting heating the camera area. Unfortunately, the 2 hottest areas of the box are where the Pi CPU is on the bottom and the infrared LED array on the top. So the camera's in the coldest part of the box, you know, just by design. If I put any more heat in the box, sitting out there in the summer, it might reach a temperature where the Pi won't run anymore.
Well, how about you open it up and put a fan?
Yeah.
Hey,
open up the chambers and put a fan between them.
Yeah, I'm afraid to open it up too much because unless that opening is on the very bottom and you have no chance of water splashing upwards into the box, you know, I'm worried about actually getting water, not just condensation, but water into the box if I put holes in the wrong place.
So security cameras usually solve this by putting a ring light around the lens.
A ring light, so they just warm the cover, the lens cover.
Yeah, because that basically they're just putting the LEDs right around the lens that naturally makes it warm.
Well, that's a thought. If I could find a way to incorporate the LED array around the front of the camera.
Look at any security camera; they're usually built that way. Look at the night ones that have built-in LED illumination.
Oh yeah, they're infrared, so that's heat basically. I wonder if is canned air dry? You know, like the ones, the cleaners that you use. It's like to clean keyboards off. That doesn't have any moisture in it, does it?
I don't think it's air.
Oh, you don't?
Well, it says moisture and residue-free, non-ozone depleting.
Okay. Of course, that doesn't mean it doesn't have a solvent that would melt your your plastic lens on your Raspberry Pi, though.
Right. It does say public safety announcement: misuse by deliberately concentrating and inhaling contents may be harmful or fatal.
Oops. So it's got something in it that could be
sound like air to me.
Yeah.
John, one of the things that I know for sure though is if you 3D printing and you want it waterproof, you've got to paint it.
You got to what?
You got to paint it. Otherwise, the 3D enclosure that's just printed off your machine will leak. You got to paint it.
Well, essentially, that's what I did. I painted it.
Yeah, I know. I'm just saying is you've got to do that. I mean, if you don't, it will leak. It'll leak water. I mean, you know, you can. So I'm just saying.
Yeah, and we're going to talk about heat from IR LEDs. This is another little board that I had manufactured by Park. You can see there's 3 infrared LEDs on it. The first iteration of my design nearly caught fire.
Sweet.
And so I looked at the design and corrected some errors, but it still runs off 300. You know, it's basically running off 12 volts at 350 milliamps. So it gets pretty darn warm.
Oh yeah.
Well, there is the other possibility, John, is that you abandon, I know this is a religious statement, but you abandon 3D printing entirely and do what most people would do in the real world, which is not use 3D printing for boxes. Like I made mine out of plywood and it's got 3 or 4 coats of paint and it's a traditional box. And
Mary,
it's-
I used to like you. I used to like you, Mary.
yeah, but you're a member of the cult, Harold. I already know that.
I approve any use of plywood.
Let's forget the rockets that are getting 3D printed now, but in the houses. But okay, aside from those,
I noted that, like none of the guys going into space are using 3D printed rockets. I mean, come on.
no, but they will. They're in
That's
the
not true. They are.
Yeah.
For the whole rocket.
The
No,
whole rocket.
there's parts of it printed, 3D printed metal, all sorts of things.
No, there's a picture I showed up in the Flipboard queue this morning where, I mean, it's the robot in the middle and it's got one of these, I mean, it's additive process, but it's depositing metal. And it's the outer shell of the robot.
You're telling me the outside of these rockets is
The
made
shell, the cylindrical shell that you see there on the launch pad, that's being 3D printed. Oh no, his mind's exploding. Look out. Now you're going to make me find the link.
Oh no, I don't doubt it. It's just a sick world we're coming to.
But okay, Marie, you can be assuaged because at the same time that robot is being 3D printed on the outer shell, it'll probably be carrying one of these wooden satellites out of Scandinavia. So
I was just gonna say, yeah, that
the Zen is restored in the universe.
Branson should make his next rocket out of plywood. I would much more approve of that.
I want to see recycled cardboard. That's when we know we were arrived.
How about particle board?
Particle board,
Plastic drinking bottle.
Old water bottles from the biking habit. That's right.
The beds that they use in the Japanese, the 2020 Olympics, apparently those are cardboard.
That's so they can be disposed of because they'll be infected with something.
No, because they don't want any two people's. The way they did it was they'll support one person, but they won't support two.
They should make dorm room beds.
Hey, listen, I don't make this stuff up.
Well, yeah, but they also said that they support 440 pounds.
I just
A guy jumping up and down on it and not collapsing.
Yeah, there was a news report where a guy,
they said.
one of the gymnasts was pouncing on it, and it was holding him. So
I think I'm gonna make my next enclosure.
He probably weighs about 100 pounds when he
Probably,
eats a couple of bricks.
When he's wet.
Hold two sumo wrestlers.
Okay, hey, so all right, so we had a queue here. So Ray, did you have more?
no, that was it.
Okay, so
I
we
was
had
just curious about what progress you made and what what you could actually get out of the thing long term.
my progress was to get you and Chris thinking about it so that you can go do some experiments and tell me what to do.
Okay. Darn, that was my strategy.
Oh, damn it. I think we had Harold in line, and then I'm wondering, so Raj, if you were and Murray, okay, Harold and Murray and Raj, I don't know if you were open-minded to give us a chat about whatever, but we can put you in queue too if you like, and anyone else. Just shout out, raise your hand. But I guess first Harold, then Murray, and then whoever else.
I'm happy since Raj is new. I'd rather have him go in front of me.
Absolutely. Please, Raj, go. New guy first.
I'm
In front of me.
just calling you out, Raj. I don't even know if you're listening or not at the moment, but if you are, open mic night.
Yeah, I'm here.
Oh, cool.
Sorry, I missed that.
Welcome.
Thank you. So did you want me to do my introduction? I missed the part. I just heard my name and I came running here.
Oh, I'm sorry. We didn't mean to make you run. I think before we started recording, we had somehow wound you up and you were going to start to describe a little about your background or interest or whatever, some context. Yeah. And then we said, and we cut you off and said, let's record, but I didn't want to forget about you. So
thank you. Thank you for remembering and giving me an opportunity. Okay. So quick introduction. My name is Raj. I was born and brought up in India, Bangalore. That's where I started building robots, electronics. My background is in electronics and communications engineering. Built a lot of projects, a lot of competitions, the kind of competition that you guys are talking about. Not this complex, but there were much more simpler ones, line following, wall following, maze solving, kind of competitions back in India. And I went to a lot of them during my undergrad and won about 30 competitions. I was big on competitions then. Then started working for National Instruments, instrumentation, test automation company, National Instruments. You might have heard of it. They make software called LabVIEW. Kind of started my career there. Then I went to CMU and Plymouth University in UK for my master's in robotics. So I have a double master's degree in robotics. Worked for Carnegie Robotics after that. Worked on a robot which is used for cleaning floors on large spaces like stadiums, indoor shopping malls, airports, etc. It was used in International Airport and a couple of other places lately. It was for a company called Nilfisk. So we're building the autonomy kit. I was responsible for a lot of sensor selection and mostly on the electronics side, testing the sensors, testing out all the different sensors and choosing the right sensors for the robot. Then I wanted to move into software. So did a lot of trying to work for a mortgage industry, building AI solutions for automation. So on a day-to-day, these days I work in Python, not on the edge devices much, but mostly Dockerize and put them into the systems. So we could do a lot of AI with computer vision and NLP. That's kind of my focus. So I manage the data science team of those things. Just moved to Dallas from Pittsburgh. And I don't have any active projects that I'm working on, but this competition seems very intriguing. So I was thinking of participating, but then I don't have a base. So if anyone's looking for a partner or teammate here, I would be happy to jump on, help you guys or help you out and be a part of the competition. It's okay if you don't give me credit. I'll be joining in the last minute. So I'll just code or build some circuits or whatever you need. I'm in Dallas area now, so close to Plano. If anyone wants a teammate, I'm here. Otherwise, I'll try to build some simple robot for the competition and see how it goes.
How can we reach you, Raj?
We want to be careful here.
Yeah, I mean, well, after the recording or something, if you want to mail us, I don't know, you could.
Well, let me ask you this: are you on LinkedIn or something like that?
Yep.
Okay.
Just my
all right. So we could get hold of you through that. Okay. I just, yeah.
Didn't want to broadcast your phone
You can
number.
join the
email
list.
world.
Yes, you can join the list. That's
D
free.
list.
The DPRG.
What list?
The DPRG list.
We'll put a link up for you.
Sure.
And Murray's going to prompt you on the Discord.
Sorry.
Just because you might not know what Kareem was mentioning is I got kind of roped into starting a Discord server called Personal Robotics, and we've got over 100 members now. So
Ooh.
we'd be happy to have you.
Yeah, I'll join in there. All right.
Well, Raj, that's cool. That's quite a background, quite a story.
Sounds like we have a ringer in our midst.
It does sound that way. I mean, I don't know about you guys, but I'm thinking if anybody's looking for a teammate, I mean, this is a call to action. So you might be hearing from me, Raj, because I have a platform, but yeah, not enough time.
All right. I look forward to hearing from you guys. Yeah.
One of us will ping you, I'm sure. But here in chat is a link to the DPRG mail list. You can sign up for free. It's there's like a few thousand members on it, but it's not a spammy list at all. So yeah, good deal. Well, cool. Maybe if you're interested at some point, 30 competitions. That sounds kind of interesting. If there is anything in there that you wanted to that you're really proud of that you wanted to show? Or, we're always looking for people willing to just talk about their projects even in the past, and usually opens up a fun discussion if you're interested. So,
sure, yeah. One of the projects that I worked on and also won a competition was an autonomous surveillance robot. This was more kind of built on LabVIEW platform. Won a competition, got my first job at NI. So that kind of, exposed me to a lot of people and a lot of opportunities. It was also displayed in Defense Expo back in India. This was in 2010. So basically put a lot of sensors on it, and it was Wi-Fi controlled. We had a map that was generated on the display, a couple of sharp sensors, max sonars, encoders. This was more on the indoor, so we didn't have GPS or anything like that. But just hacked around with all sorts of sensors that I could get hold of in India at that point of time. I had to import the sharp sensors from US. But apart from that, we had like a camera. We had a camera mounted on servo motors. It was still pretty complex at that point of time, and nobody at that point of time in my college had seen anything that complex. And kind of what we heard from the judges who were judging the competition, was a national level competition in India, and they also said the same thing. They're not seeing anything that complex. But I mean, we were just building all these robots, and we just took that knowledge and built this indoor navigating surveillance robot. And we could have a map showing where the robot is and where it's going. It was building as it was going. It was not exactly SLAM, but some variation of it. Yeah, we took that robot to a lot of places, got me a job at NI, and it was pretty cool. I have a video. I don't have any of my robots here. I didn't want to carry that in the plane, a 30-hour long journey from India to here. So I am still unpacking my boxes here. I have a couple of robots lying around here that I built lately, but I am interested in building more. But yeah, I still have to unpack everything here. Just moved to Dallas last week.
Well, welcome.
Welcome.
It's great to have you on board. Yeah. We have not met in person really since March 11 of last year, but I'm starting to hear more and more groundswell to try and find a hybrid model. So I think maybe certainly after this August competition, which will be mostly outdoors at someone's house, well, we'll know our common sense and feeling for where COVID is going, and our interest in how to split it up hybrid in person. So basically, it's if you saw the rules we posted earlier on, there's 3 cones. You put your robot at one cone and hit go, and they're fairly far apart. So you've got to be able to go find the other cones, get around obstacles, and there's points along the way. And it's a kind of rough terrain like grass, and so straightforward stuff for people that do like delivery robots in downtown areas. But for people that are just rolling their own in a garage here, it can be a lot of work, right? And without the formal robotics degrees, most of us, I'd say, are in some kind of technology industry, software, hardware, mechanics, but I don't know that many of us have formal educations in robotics, but there's a lot of really hands-on practical experience that's quite valuable here.
Hey, I was first a hacker kind of guy who built the robots before I had a degree. So yeah, degree just went into a lot more complex stuff, but which may or may not need to use it here. So yeah, I'm cool. I like the spirit of building robots. Not really thinking all the way through and getting into a lot of maths and coding it, simulating it first and then coding it, but just get into it, get something moving, and start programming as it goes. So I love that spirit. I love competition. I didn't get a chance to be in a lot of competitions before when I came to US, but I'm like really excited for this competition next month.
Well, that's neat. Well, even if there's nothing to run, I think it'll be a fun gathering. At least it was the last time we did it there in person. So, yeah. Oh, good. Well, welcome. Looking forward to hearing more of your projects and working together on something. So, good deal. Okay, so with that, anything more, Raj, or should we move on to Harold and then Murray?
Good for now.
Cool. Mr. Harold, I think you put a nice post earlier, so you got a meetup tomorrow night.
Yeah, I do. I just and I'll post it back up again in case so you don't have to run off anywhere to go get the thing. It's coming in hot. There you go. Just hit chat one more time. They've got a meetup tomorrow night. It goes from 6 to 8. We're actually having it in person at Improving. I will be serving pizza. I will be serving pizza. And for all those that show, I say all those show it up. I think we're going to have 8 or 10 people that have signed up. How many show? Don't know. We'll see. But it is hybrid. So I will be blowing this out through Discord using OBS and its virtual cam, and I will also be streaming it live on my Twitch channel as well. So there's plenty of ability to come hang out with us. I'm going to be talking about the XMI robot from head to tail. In fact, I do not have it in my garage or in my lab tonight because it is actually at work because I was trying some things to make sure, since it's his first trip, out of town, so to speak, how making sure things were going to go and I could demonstrate the thing running around and actually driving it. I'm finding some things I don't like, but that's okay because we get to improve it. I will tell you, I'm having some issues with it. Last week I talked about my IMU and my tiny LiDAR not playing well together. Not resolved that yet, but I figured, okay, that's nice to have, but I really need a GPS so I kind of know where I am. And the GPS is reporting stuff into ROS, and I'm pulling up, there's a topic called /fix, and I'm pulling information from that, and it looks right. Well, I don't know if it's right. I am getting data, and the data is changing when I move the robot significant distances around my property. So I think that's pretty good. What I'm not getting is there's a thing called UTM to put that in a global or local frame of reference for the robot. It's a coordinate system. It's got a funky name to it. I can't tell you what the M stands for, Mercato or something or other. I'm sure one of you folks have probably heard about this before, but what's happening, I've got a ROS node that says it's subscribed to the fix topic, and it's supposed to be putting out odometry, which I'm not 100% certain what that odometry message looks like, because I'm trying to the point where I'm trying to throw some data at it and have it spit some data out in the odometry topic, and it is quiet, zip, zero, nada. In fact, last switch stream, I spent the whole time trying to get debug messages from that C++ deal to actually show up somewhere where I could say, oh, I got a debug message. Now let's go do some real ideas about how we debug these things. So I'm banging my head on that. I'm not ready to give up the ghost, but I know I'm running out of runway to actually do very much in the contest. So hopefully it'll be, I'll just run over the cone, and so I'll get a point, and so I can say I did something. So hopefully I'll be able to do that. I have started taking pictures of the cone, but I have not started doing my cognitive services stuff yet. But that is coming here pretty quickly on that. Training that thing up won't take too terribly long to do. It just is. I've got to wiring all these things up to put it in drive mode, to literally, if it finds the cone, to just put it in the center of the field of view somehow, and then run it over. And I'm like, oh, okay, we ran it over. Great. Let's go find the next cone. And so, well, I know I'll get a time thing, but my robot's so slow anyway, it doesn't matter. It's pretty slow. So anyway, that's how all that's going. And I'm really frustrated at the moment with this ROS thing and not being able to see debug messages. I'll eventually figure it out. But I've got some helping hands. I've gotten 4 or 5 people here recently hanging out in Twitch with me, offering suggestions. A couple of them are. So I'm like, okay, cool. That's awesome. So as I mentioned before, if you'll pin me up so you can see my screen, I'll tell you about this Docker thing. Unfortunately, I can't run it because this is a Docker file that would run on my robot outside of a Raspberry Pi. And what I want to point out is a couple of things. Murray had his script to go set up his Pi, right? And there's a few things there. Sometimes you have to be root, sometimes you don't. If you look at what I've got going on right now, let me make it one more bigger. Come on. One more bigger. Okay, got it. So what happens in the Docker world is that you're running on top of a host OS. So the only thing in your Docker container are things that you want to add to that host OS. Add to. The only thing in your Docker container is the only thing you care about it being in the Docker container. You'll get a bunch of basic stuff there, like you'll be able to log in and do all the stuff that you had in a Unixy sort of a box. There's an image. If you look at the very first line, where this is line 2 from ROS : melodic, there's an image repository very much like there's a repository for GitHub for source code. Except in this case, the melodic is a ROS built image already from the ROS Foundation running under Ubuntu, and you get all of that stuff already done when you go pull this thing, and it runs it for you in a container on top of the OS, whatever OS that is. Depending on if it's a Windows based, you got to do some extra things. But if it's Linux based, you just literally get in there and say Docker run, and it runs the thing. In this case, this is going to build an image local to you, then you can run that image. And if you'll see where I set some few things like the ENV and online find, where I'm doing a symbolic link for some stuff, that's all running as root. You're root right now. And the basic tools, where you see the apt-get update, I'm sure we're all familiar. If you played with this very much, an apt-get, I'm running an apt-get and going installing all these tools that I care about. And you'll see I've installed a few of them. I even went so far as installed this pip one down here. We're talking about pip before, installing libraries, all that sort of stuff. That pip install gets run for me every time that I go change or update something, or it will go check to see if I need to update this Docker file. And I wanted to go pull out some stuff, and especially down here when I'm talking. This is some stuff I've added. The SM Bus 2, so I can deal with the I2C stuff. All of this is stuff I've added for my GPS and library and all the other Python libraries and all the other things that I need in addition to what the melodic would have out of the repository. It goes through and runs, updates the bash RC on the thing so it knows about, put some stuff in there so it'll run and set up the path automatically for lots of stuff. Set some ENVs there where I want to be. And then this entry point is another application that gets executed. And I don't know if I can show you that here. Yeah, maybe I can. This entry point is nothing more than a bash shell script that runs when you run the Docker command or run the Docker Docker file. And all that is a file that lives on your desk as an image. And sometimes I'd like to show you, but it's all on the Pi and it's somewhere else. And sometimes this image is only, a few megabytes big, and it looks to you like a complete operating system for doing whatever it is you want to do. And like I said before, the cool thing about this, I can go in here and I can have this Docker image going. I fire it up, I run it, I run all my commands. I'm like, really, I need to put Telnet on here or some other stupid thing to try to do something. I put it on there and like, no, that didn't help me. So I just kill the image, either remove the image. And I just exit out of it, remove the image, run this thing again. And in about, about 30 seconds, no more than a minute, I'm back to some usable thing that I've had before. So it makes things really usable. Now I'm just using it for this ROS stuff because I've got that ROS image. But if you wanted to use it for anything else that you're going on, like I've got, like if you got microservices that run, um, and you want to put them each in their own ROS, and I'm sorry, each in their own image, you could do that in a Docker file. And there's a thing out there called Docker Compose. Docker Compose looks at a make file, and it will make all these images up for you. And you say, in Docker Compose run, and it'll run them all. So you have all these things popped up for you to do. It's really, really cool. I will tell you, it seems imposing about what's all this stuff and where do we go and what do we do. But after you get kind of into it, it works. It's really an effective way to build stuff, and especially in the ROS world that I'm playing in, the ExoMy guys did a really good made a really good choice to make this Docker image, because in this case you put all the parts together, slam them together, you configure your Pi enough to run Docker and get it online where you can talk to the outside world, and then you Docker run, and then you say, hey, I'm in configuration mode, and in that mode it runs a different thing for the entry point, different section of the entry point to drop you in a place where you can say, where there's some stuff already set up to, okay, now I'm adjusting the wheels, or I'm adjusting the servos, or I'm doing some other thing. And then when you're done with it, saves all that stuff in a different file that's persistent on the host machine. You run it again and you tell it, hey, I'm a developer, or in this case, what I would do going on during the contest, or because if I just wanted to fire up and run all by itself, they've done a real nice way of setting it up to say, you go, hey, Docker, run this script and put me in automatic mode. So it sets some stuff all over the system so that when this Pi boots up, this Docker container boots up, and all your stuff is ready to go. And you just as soon as it comes up, they'll start rolling. It's pretty cool. It's pretty cool. You can tell I'm a little excited about it, right? On the thing.
So, Harold, if I understand what you're saying, because I've only just kind of tangentially listened to this Docker talk. On the Raspberry Pi running Raspbian, which is what we think of as its default, you're saying you open up a Docker thing, install Ubuntu, and it's running inside there.
Yes.
The Pi thinks it's running both at the same time, basically.
The Pi thinks it's running an application, which is in this Docker container thing. And inside that container, the application is running is a complete, or can be a complete Ubuntu OS. So depending on what your needs are, and in this case, the ExoMy guys decided to do this by, they were trying to write directions and things to put on a Raspbian, or Raspberry Pi OS, I think is what they call it now. And they were trying to put it on there and then give you directions how to install ROS directly on the Pi. Having done that myself, and I agree with them, if ROS, if you're not running Ubuntu on it, ROS really likes to run in Ubuntu, at least the directions that they give you to do things on, want to run there. So they were having a hard time making that happen. And so they said, well, why don't we just get a Ubuntu base image, apply our image to it for the raw stuff, and then from then we'll add a couple extra things to it, and away we go. Basically, you're stacking stuff. So the base image is like a Ubuntu image you can pull that's public available from Ubuntu. You don't even have to build it. And then once you got one of those, then you can use one of these Docker files to add other things to it to make it be and have whatever doing. And in the application that we're working, that I'm doing at work, we needed a way to produce PDF files, and we're using headless Chrome and firing HTML at it to get these really nice reports. And it turned out to be way easier than like SSRS and a bunch of other report generation things, and way cheaper than firing up an entire VM somewhere in Azure just to run this one application. And we had some problems with it, with things changing, versions changing. So like, hey, let's make a Docker thing. I pick the versions I want, just like I would do in GitHub, and have it in a Docker file, install just the things I want with the versions that I want. And now I've got this image that, as long as we don't have to change that image, and even if we do, if those versions still exist, which they will for hopefully a long time, I can run this Docker image in the cloud or on another operating system and get what I'm expecting to get from it.
Well, Harold, I have to say that once again, you've made my life better. I'm going to investigate this.
Yeah, go investigate it, man. If you need help with it, or if you want some more talking about it, I am not an expert. I mean, I know I probably sound like it now, but I am not an expert. But I can certainly walk you through some things and show you some stuff. And there's a lot more depth than I've ever even broached on all this stuff. But it's really cool how it works, because I can't tell you how many times over the past couple, 2-3 weeks, a month, maybe even longer, that I was doing something and I'm like, oh, let's install this thing. Oh, that just shot it all to hell. Damn it. Okay, exit, kill it, run it again, and I'm back to where I was.
Yeah, I had a project I thought I was going to have to use 2 Pis because one needed to run the Android and one the Raspbian. So maybe this will make it all on one.
I think you can do that. I don't know that there's an Android image out there that you can pull down, but I can't. It would be
worth investigating.
It is worth investigating, and I would bet a whole bunch of money that thing exists. Now, how well that works, I don't know, but I bet it exists, or somebody's trying to make an Android Docker image that you could run stuff on top of.
Cool.
Yeah.
Thanks.
You're welcome. You're welcome. And that's about all I got, I think. Also, come see me, tomorrow if you want. Get on there. We're on the Twitch as well. So whatever you're most this is the first time I'm doing all of this at the same time in a location other than my broadcast studios, my garage. So I don't know how well all this is actually going to end up working. And so we'll see what happens.
Harold, will you have one of the bigger rooms up there?
I am going to have, there's also, this is Cosmic Collision. DFWmobile.net's meeting, they have several people. I'm going to have it's called Excellence. If you remember, Carl, we got 2 rooms that have a divider. I will not have those 2 rooms, but I'll have the one next to it. So it'll hold probably, I've got 10 people on the waiting list on the list right now, and it'll easily hold 8 to 10 people separated out like that in a comfortable manner. If it gets much more than 10 people, it's going to get a little crowded for that room.
Okay, cool.
Yeah. And I was working on the presentation tonight. My presentation so far is two PowerPoint slides, and one of them is just simply a list of notes so that I will know what subject matter to go over and not get squirreled away, because I've talked for a long time, as some of you might know that. So
you've got your robot covered anyhow, so you're good.
Yeah.
Well, cool. Well, thanks.
Not a problem. Not a problem at all.
Okay, then let's see. Next, I think Murray, Shopper Deluxe.
I have got a lot of stuff going on. Yeah, my birthday's coming up, so I bought myself a Pi 400 and one of these cyber decks, and I've got the Hyperpixel, so I'm going to plug all that together. But that's not related to robotics, so I won't talk about it any further. I got a nice big shipment, though. I got one of these, so I'm going to try the display that Carl did. On the subject of robotics, I have 2 robots. I have my letterbox robot over here, which is now a plywood box that has been painted and waterproofed and has a box on the top with a camera, and will turn on a 2.5 meter strip of LED lights along my path at night when someone walks by the PIR sensor. It has a camera looking down to tell me if I've got any mail, and I just received if I can find it, my little magnetic switch thing that will tell me if someone opens my letterbox. I get an alarm, the whole house will turn red, and someone has opened. Anyway, that's my letterbox robot. Now, on the subject of my robot operating system, KROS, I have had some successes, and I have some controversy that I will bring up, as I always seem to. I can say that if I can hold this up, it's kind of on the heavy side. It's actually, this is my KR01 robot, and I'll start the OS now. And this is not gold star kind of material, but it is silver, maybe bronze star. The robot operating system is now running, and I've got a digital potentiometer here. And if I turn it, Ow. Yep, there we go. The wheels rotate and they go backwards as well. And what's happening here, I know this doesn't seem impressive, but what's actually happening is I have my message bus receiving velocity messages, which have a value coming off of this. And I'm actually responding to those messages by altering the motor control. So that actually is now functional. One of the things I have been discussing with people in the personal robotics group is we've talked about slew limiters, and apparently, according to a guy with mechanical engineering background in Mississippi, he had not heard slew used in this form. He knows of slew as a term in like op amps and things, but I convinced him that I don't want to start using a different word for that. But slew, of course, is how fast something changes in acceleration. And he let me know that there's actually, I think, 3 or 4 other terms that are used in physics. One is after slew or acceleration is jerk.
Yes, the 3D printer.
Snap,
3D printer
snap,
guys. 3D printer guys are all.
snap, crackle, and pop, which are different levels of mathematical derivatives. And I was trying to find out what the next one is, which is I've got a slew limiter, which is now got both an enable and a suppress flag, but I've actually now implemented a jerk limiter, which the slew limiter, of course, keeps the robot from speeding up too quickly or slowing down too quickly, but I also don't want it to jerk too quickly. So I've now got a jerk limiter, so it can't go from full speed in one direction to full speed in the other direction and destroy my gears or something. So that's what you saw on the robot now is not using the slew or jerk. It's basically just direct, and I haven't quite worked out that because I had my slew limiter implemented, sadly, within my PID controller. And as David has told me before, get everything out of the PID controller. And so I've been pulling everything up to a higher level. So now I've got a class called motors, which has all the higher level motors control, like braking and things like that. And it sends messages into the motor class, and the motor class is now where the slew limiter and the jerk limiter live. And then it sends messages on to the PID controller. And so I'm getting there. I'm getting pretty close to having a functional robot again. I mean, the message bus now demonstrably works. It's actually receiving messages and controlling the motors. And I haven't incorporated the PID controller into, well, actually, no, that is the PID controller running. But it's not quite integrated everything together yet. But the message bus does work, and I'm not having any communications problems at all anymore. And I'm kind of busy with a few things at home, like flooding basements and stuff, but it's all coming along. And I'm quite happy to say that the robot operating system is, so far as I can tell, functional, and I'm not getting any noticeable lag or performance problems. I'm running at and it's not, I mean, part of the difficulty we've had in communicating about this is that, and I think it came up last time, is that there's kind of like these two paths that that subsumption architectures or things like that have taken. And in our last video conference, we talked about how, on one hand, the MIT early research kind of went one way, and then it kind of branched off another way. And it turns out I think I'm closer to that earlier branch that seems to have died, in that I actually do have a suppress and enable flag on every single behavior. And so it's a little more, maybe you call it traditional subsumption architecture, because since the 1980s and 90s, it kind of has gone somewhere else. But I've at least demonstrated that that can be made real, and that I'm using an asynchronous message bus in Python, and that the actual 20 hertz loop or 25 hertz loop that most people who are using microcontrollers are using, I don't actually need that. It turns out that if you run entirely effectively like interrupts, which is what these messages are, they're asynchronous messages being sent by sensors and things, that the system reacts to that, and that you could have loops, let's say, for example, on a sensor saying how often it should poll, but the whole system as itself is actually entirely asynchronous, and all the messages are simply prioritized and sent in, and then we have subscribers on those messages which choose which behaviors to implement and suppress or enable. And I don't think I've invented anything here, is I guess what I'm saying. I think that what I've done is tried to implement what I thought was some of the sort of Rodney Brooks style subsumption architectures, and unwittingly caused some controversy, because clearly some people in this group have got things that are the second branch working very, very, very well without actually having implemented those kind of earlier ideas that Brooks has in some of his papers. And so I am familiar with what some of the things that David has done, certainly, and I've looked over his code, and I ended up not quite wittingly, I can't say unwittingly, I kind of knew what I was doing, but I kind of ended up with the earlier structure in my code that I had seen in the original Brooks papers on subsumption architectures. And so far everything's working. So that's kind of the end of story for today anyway. I know it's kind of getting late there. But
That's cool.
Cool.
You got moving wheels. That's is that the first moving wheels we've seen tonight? I mean, that's a statement, but
well, it's Bronze Star material because it's not quite, but yeah, I'll show just one more time.
Yeah.
Yay! Moving wheels.
see that? You turn a knob, many
And-
messages pass, and the wheels turn.
This changes color. Isn't that cool?
That's phenomenal.
And I've got a little hysteresis in the middle. If it's anywhere near 0, it turns off the light, so I know that I'm at 0. So
Cool.
anyway, the robot weighs about 5 pounds, so it's kind of hard to hold up in the air. But
That's pretty much every IoT device has got to report temperature somewhere, have an RGB LED, and there you go. It's kind of the rules. So
Nice.
anyway, that's it from New Zealand.
Cool. That's good to see. Good to see progress.
And I'm very happy to see Raj in the group. I look forward to seeing his participation. We can certainly use more viewpoints. Should be really cool. Welcome.
Yeah. Okay. So anyone else? Who else? Let's see. We've heard from
I have something if you want to see.
Don. There you go. What you got?
So let me pick the window. Hopefully I'll get the right one. I thought this was sort of neat. As I was surfing the web, I found this in Strabo. So basically it combines a couple things, as you can see, a dog and telepresent, and I'll run the real thing there so you can sort of see this. I don't think it makes sound. Or if not, I can speed it up a little. Yeah, he 3D prints it. So let me skip through that part. Yeah, okay.
You got to train your dog to eat out of a bowl on a robot.
No, you don't have to train the dog. You can take the bowl to the dog.
Oh.
Okay.
And hope the dog doesn't attack the robot.
Well, now that may be the case, but
because Doug's dog does not like robots.
yeah, but eventually, if you feed the dog, it may be happy.
No, my dog would kill the robot and take the bowl.
But I think John's point is good. If the robot starts to feed the dog will start to like the robot.
I've tried doing that with my robot by putting treats on the robot, and the robot would have treats for it, but he didn't care.
I think this would work at some bars, right? Basically, you put nuts in there and.
Oh, now he's toying with the dog. He closed the lid on him.
Like, really? Really? Do I have to eat out of here?
And then the lid closes. This is cruel and unusual.
I think we should call the SPCA on this guy.
How to train your dog to attack robots.
I want to do something like this for my daughter's cats.
Yeah.
I can say my cat really doesn't care about my robot at all. He just ignores it.
So, as I said, I thought that was cute. But main thing is that it's pretty well documented. So, he goes over the design, the materials, uses separate motors. And let's see where else we go. Hazards. And then he talks about the electronics. Sonic. So yeah, it looks, pretty good, well documented. That's everything. Talking about the cloud and creating the app. So yeah, I thought this was a pretty good overall one. I don't know how far we have gotten with our remote robot regard to it, but basically this is a variation of that.
Cool.
So
Are you
yeah,
going to build one, John?
what? I don't. Well, I don't have a dog or cat, so
That's pretty
for
good that
me,
you get one.
You could always have it bring you treats.
now that's a thought, but yeah, no,
John,
I'm
you can
thinking
always
more
3D
along the
print a
lines of
battery
something
cell.
like this if I were going to build that.
Quadruped.
But
Yeah.
I thought this was a well documented one, especially for a remote robot. So that's what I found for today.
That's pretty cool.
I'll say this. If you haven't looked at Instructable's Arduino contest, which I think
Yeah.
it's ending in the next couple of days, there's several projects in there
Yeah, it's
that are
interesting.
really, really cool. They may not be all robotics, but there's some really cool projects in there.
Yeah, somewhere he mentioned about that robot contest, but he doesn't have a link right there. At least when I click on that, it didn't go anywhere. So
If you want something to build that a dog will enjoy, I've got a 2-minute video I can show you.
okay.
Just real quick here. I don't know how many of you have seen this. This guy built a tennis ball launcher for his dog. And the dog plays with it. He brings the ball back, puts it in the launcher, it inclines, and fires.
Cool.
So the big question is, which one wears out first, the dog or the robot, right?
I don't know.
Looks like a big launcher. Wow.
I have been requested by an office mate of mine to see if I could make a treat flinger. Specifically, not exactly that cool, but
If you got a Jack Russell Terrier, this is perfect.
yeah, it is. Those dogs have too much energy for anybody's good, not their own anybody. Anything's good.
I think you probably wear out the robot on one of those, yeah.
Now, obviously, he had to train the dog to put the ball there. That's pretty impressive. Pretty impressive feat.
That's great.
Look, there was a behavior there that looked and say, "Hey, I'm going up, but I really don't have a ball. I need to go back down."
And the
Yeah,
dog
hopefully it
clearly
doesn't
loves
smack
it,
the
so he's
dog in the
satisfied
face.
the dog, man.
He started biting on the slingshot there.
So now he can wear his kids out too. Cool. What do you do with a 15-year-old though?
It's a good way to get your kids started in robotics.
And your dog.
And your dog. That dog's a little fat there.
New dog.
That looks like a really mean dog.
Yeah, that's definitely little man's disease going on with that dog right there.
That's
Potentially.
the dog that bites the paper boy's bum, which I can speak to with some experience. I have a scar on my bum from a dog like that.
So since there's this break in the conversation, I wasn't going to show this because it was so little to show, but I was talking last week about my wiring problems on my telepresence robot. And since Murray showed his wheel spinning, I don't know if you can see these, but spinning.
Oh, look at that. We got wheels to spin.
I finally got the wheels actually spinning again. It was
Damn
a
it,
big
Doug.
deal.
You
It's taken me
stole
2
my
weeks
thunder.
to do that. And it turned out it was wiring was bad. I had to practically redo all of the wiring inside, and it turned out the last thing I fixed was the one that was broken. These little
Always.
DuPont wiring things have such thin wires in them that they just break too easily. I need to get thicker wires for my robots. But now that I have it actually running on demand and going forward when I say go forward, I can go back to doing it remotely and get the telepresence part working.
Cool.
So, yay, robot wheels turn.
That's awesome. Robots turning, robot wheels turning. Hey, so Doug, have you given thought to how you would share your telepresence robot to invite people to use it?
I've given some thought to that. My plan is that I'm going to have the telepresence part of the robot, which is probably a mobile phone, possibly an iPad, and it will use something like Skype or possibly whatever that Apple version is. The Apple version is kind of an Apple thing, though, and Skype, I think every platform runs Skype.
Yeah.
So the plan is that by Skyping to the robot's phone, you now are the telepresence person on the robot. And then, as I showed several months ago, the real VNC allows the person on a separate screen basically to control the movement of the robot, and they have a camera to show what the robot is moving around that's separate from the telepresence view that you have through your phone. And the plan is that probably one person at a time. I don't know if Skype does multiple things like Zoom, and it probably wouldn't be very good telepresence anyway. But hopefully we can get more than one of these that the club can have available to be using. And we can say, okay, you're on robot 1 and this is its credentials to get into, and you're on robot 2 and here's its credentials to get into.
Okay, so you were thinking to just make it available and known, and then we would off to the side work whoever had the logins and how to arbitrate who was using it. Okay.
When I show up at a meeting, I'll bring it and we can pick somebody that's remote and say, okay, you get to use this one.
So for those that might not be aware, we're talking about at the start of the year, before we got talking about the outdoor competition robots, we started talking about, well, what do we do when COVID starts to wind down and we have a mix of in-person and remote participants? And the thought was, well, we're a robot club. We should be building a telepresence robot that people could drive around. And well, it should be more than just a teleoperated thing. It should have smarts. You should say, hey, go over there and drive. And we should have some fancy whiz-bang API so that anybody could build a robot attached to the API. So at the end of the day, that lasted for a couple months, that discussion. Doug has gone on and built one. I've gone on and Donna from Seattle raised a project. So we have basically two different things. There's no common API, and we have a first potential interactive hybrid thing coming in late August. So Doug, what I was thinking is that however you work yours, what I was going to do for mine, for those who haven't seen it, this is my base built off of the 2016 DPRG club platform, and it has an Arduino Mega in the bottom and a Raspberry Pi on top. So I was going to have another tripod on top that I would bolt a Zoom to, or a Google Meet or whatever. But the framework that I have for remote control of the thing uses AWS infrastructure and a web client. So I have actually what I did in the last week and a half or two or whatever after surgery was I got a website started now so I can test things out, and I'm using it to gather. I'm using it to learn mainly about web analytics and Google Analytics and big data and some Google Tag Manager and things like that. But to get the data on the website, I have robot content. So I'm going to send some links out probably between now and next Tuesday and ask if you guys could just click it, get some traffic for me to look at. But eventually then by late August, what I hope to do is have another link on that website that has a sign up page, and you could go to that link and you could say, hey, I want to drive the robot, and then I can grant rights. And then that's how I was going to allow people to drive this around. I was going to disable forward motion, just let it turn, and have it sit on the table over lunch at the August contest. And then people could tele into this thing and then sit at the center of the table and spin around. So not terribly exciting, but better than nothing.
Proof of concept.
Yeah. You know?
Well, you had mentioned that you were going to use Google Meet or Zoom for your telepresence part. And
Yeah.
I thought about that too at first, but it doesn't really behave like a telepresence activity, because a telepresence robot, to me at least, is a robot has my face on it, not everybody's face. And with the Zoom, you don't have a camera that's showing you what you're seeing in front of the robot.
Well, yeah, well, it could, right? Because you can say, I think because basically for the camera, the Zoom part or whatever it is, Meet, it's going to be a phone. And for the phone, I'm pretty sure you can say use the front-facing camera, not the rear camera.
Right.
And then in the Google Meet, you can say pin this photo.
So like in this case here, I have 12, 13 pictures on my screen, and one of them would be what the camera is seeing.
Yeah.
Okay.
Yep.
That's functional. Yeah.
And if you think about it, the whole ExoMy project was, so far as I remember, those two guys basically saying that they're going to have a big exhibition coming up, and they wanted to build a robot that was a telepresence robot that people in the crowd could actually run. So, you know, that's a real obvious use case to get people interested in robotics, is let them drive a robot.
Yeah.
Right.
Yeah, in fact, out of the box, that Docker container I was just talking about pops up a web application where you can go hit that with a, you know, if you're on that local IP address, that you see the camera there in the middle of it. You have a little a control to move it left and right, and a way to control the steering type, whether you're crabbing, which is my favorite thing to do, or Ackerman, or spinning in place, that sort of thing.
Harold, I would have thought spinning in place would have been your favorite.
I do that too much anyway, man. You know that you remember that back in the day, those sit and spin toys, man. I got on those way too much.
Isn't that part of our job description these days? Sit and spin.
Seems like it, I'll tell you that.
I think so. But how's that for another idea, though? I don't know if we've talked about this before, but it just stuck into my mind. For since this is an outdoor competition and there's going to be robots driving themselves looking for cones, why wouldn't we have try and talk some of the competitors into putting a phone on their robot for first-person view into the Meet?
That's a good idea. I don't think my telepresence robot could make it through the grass to follow the other.
No,
but
if David and Scott are going to bring theirs,
and anybody with an ExoMy could bring an ExoMy. I mean, that's
Harold will have his.
Yeah, I have mine for whatever that's worth. We'll see how much I can get. I've been beating my head in. Hopefully, I'll have a breakthrough. Hopefully, something will work. You know?
I can help you.
You guys know that story. You guys know that story.
I just had someone knock on my door a little bit, trying to get me to sell my house. That's how bad the property market is. They're actually walking the streets now, trying to get people to sell their houses.
I get probably half a dozen phone calls a week asking the same thing.
The hot market around the globe, I guess.
I guess so. I gotta go, peoples. So,
all righty. Yep. We'll see you later, Murray. Is there anyone else? I think we've gone around the table. Okay, hearing nothing. So it sounds like we had a good discussion tonight. Everybody have a great weekend and week, and catch you next week.
Yeah. Good times, everybody.
Okay, we'll see you. Good night. Raj, I sent you an invite, by the way.